Will we let them sing you a song? Ooh, ow, 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 ow. Ooh, ow, 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 ay, yeah, ow, ow, yeah.
Hello, welcome to another stream. How about that? Welcome. Hello, hello, Mr. Botka, loading BG, Out9, Yatanasov, Nafli, Jezem Golu, Zeroj BSP, Lost Algorithm, go on the third, Jiang, thank you, Jiang, for the subscription. Thank you. Esther, hello, I saw you raided me. Thank you so much for the raid. Thank you. All right, so today is Thursday, if I'm not mistaken. Right, and that means today, according to the schedule, we're supposed to be doing Advent of Code. Right, but I just don't feel like doing Advent of Code today. I'm really sorry. So yesterday I started to work on my compile time evaluation in assembly. And I kind of want to continue doing that today, so I really apologize for to all of the people who joined today for Haskell. So there will be no Haskell today. So today we're gonna do a C. So yeah, I'm gonna continue developing our virtual machine. I'm not sure if it's interesting to anyone, if this project is still interesting to anyone, but it is interesting to me. So and I think I can get it to the interesting place where it could be actually useful. So yeah, the last time Haskell pissed you off. No, it's not about Haskell pisses me off or anything about that. So yeah, thank you for being such an expert in me. All right, so let me actually start the TeamUX and let's go to the virtual machine. All right, so let me check out the master. By the way, I finished the work off screen that I studied yesterday, so now we have the actual AST tree for the expressions. It's not used for anything useful yet, right? It's not used for anything useful yet, but today, hopefully, we're gonna actually add something useful there. We'll see how it goes. So, and I also, wait, pull request. Is that my pull? Ah, it's a Nico's pull request, work in progress. Okay, I thought it's my pull request that I forgot to merge. Yeah, so math operations. Bindings do not support expressions. Okay, this is very important. This is basically what will make this kind of stuff useful. Let me fetch the other stuff and maybe merge that. I don't remember if I actually did that. I don't think so. Merge origin master 172, and let me rebuild everything just in case. So probably also want to run the tests just to make sure that everything's okay. Yeah, I ran the test before. I mean, I wouldn't be able to merge my changes without tests passing, so it should be okay. All right. So let me see. So it's gonna be BM. All right. So essentially, what I'm gonna be doing right now, if you try to do something like this, where you try to define the variable, rather binding, in terms of another binding, it will not compile because this is something that we do not support right now. So, and this is going to be the demonstration of that thing. So let me quickly do that. And as you can see, binding cannot depend on other bindings yet. We're working. That's a nice compilation. I completely forgot that I actually made this compilation message. What a nice compiler. Oh my god. Okay. I totally forgot about it. Alright. So... and that's exactly what we're gonna be doing today. Yes, we're gonna work exactly on that. Whatever compiler said. So essentially it's gonna be very interesting, right? So we have an array of bindings, and each binding corresponds to an expression, right? And we need to be able to basically resolve a binding, and when you resolve a binding, you evaluate the expression, but the expression may depend on other bindings, so which will trigger a recursive resolution of that binding, and so on and so forth. So it's going to be a recursive process. And at some point, this recursive process may become cyclic, right? So, yeah. It may become cyclic, and we'll also have to deal with that. But it's actually super easy to deal with that. At least I don't see any obvious pitfalls on dealing with that. It's actually pretty straightforward. You do a DFS, and throughout the whole path of your DFS, you just mark all of the nodes, and if you hit the already visited node, you found the cycle. So it's actually pretty straightforward. And then once you find a cycle, you report an error, and while you're marking everything, you can also provide additional information, so you can report this kind of situation like better. So yeah. All right. So, hello Esther. Welcome. Thank you for the rate. I saw your rate. Thank you so much. So yeah, today we continue programming in C and improve our compiler. So that's what we're doing today. Alrighty. So let me take a look. Have you thought any thoughts on what you're building on top of the VM? The assembly. So why not? So it's built on top of the virtual machine because it uses some of the part of the virtual machine. So I'm literally building things on top of the virtual machine. As a matter of fact, I haven't changed the core of the virtual machine for quite some time. The core of the virtual machine has been stabilized for like a couple of weeks already. The only changes I usually make are to the assembly, because this is the most interesting part. So I'm adding more and more compile time features, but it still compiles down to the same virtual machine. To be fair, I'm actually thinking in the future to continue developing my x86-64 translator, right, which takes the bytecode of virtual machine and translates it to x86-64. We still have a lot of instructions not implemented, but apart from that, like, I don't need to think about that. I don't need to think what to build on top of the virtual machine. I have a lot of stuff on the top of the virtual machine. Would you recommend learning Go if I already know Python? I don't think just mere knowledge of Python should be a criteria on deciding whether you need to learn another technology. I think the criteria, in my opinion, should be a little bit more complex, right? So you also want to know your goal, right? What you're trying to achieve. You also need to know what you're interested in and stuff like that. I don't think such a choice boils down to just yes or no whether you know Python or not. It seems pretty oversimplified decision making, to be fair, and yeah. Rust or Go what? Alright, so let's continue. You guys are just trying to annoy me with questions. Okay, so Binding kind. Where is my binding? Here's the binding. So right now, yeah, here it is. Here it is. 177. 177. So here's the binding kind, and to be fair, I kind of want to get rid of the binding kind, right? Because I think it should be a type of an expression. Binding kind right now represents a type of an expression. So yeah, but getting rid of that is going to be kind of difficult. So I think I'm not going to do that right now. And on top of that, if I'm going to introduce the types of the expression, where's the music? Oh, music is there. The type of expression, I need to think how I'm going to be converting types and stuff like that. As already mentioned, I'm planning to have a hierarchy of types. Let me actually quickly draw it super quick. I'm asking because what I want to make in Go, CLI and Beckett, seems to be possible to also in Python. Well, congratulations, GeForce 4760. You just answered your own question. You don't need an expert opinion of some random person in the internet to tell you what to do. You literally just answered your own question. Furthermore, you even analyzed the situation and came to the conclusion of your technical decision. Like, why am I here? Like, you don't need me. Come on. It's just you made the decision. So, and furthermore, I don't even know all the details of your situation. So how can I possibly give you any sensible advice? People. You need to grow up already. Come on. You need to start learning how to make your own decisions. Stop being children. All right. So, again. So right now we only have like types number, right? So we only have number. Right. And the other things we're gonna have are like this. So then an integer and then a float. He doesn't have enough tech experience to make an informed decision. To be fair, looking at the quality of software in 2021, nobody has technical decision, the knowledge to make right technical decisions. So, yeah, I wouldn't be ashamed of that. Don't worry, if you feel like you don't know anything about software development, don't worry, nobody does. Just look at all of the slow, crashy applications these days. Nobody knows how to develop software, don't even worry about it. So yeah. What's up, Valentin? Thank you for...
The answer is always to learn more Python, размышляет.
Thank you so much for 18 months of tier 1 subscription. Thank you. And welcome back to our software development club, where we make informed technical decisions, always. Yes. Cheers, by the way. Alrighty. So, and an integer is going to be signed and unsigned, and the reason why I want to separate them is that because multiplication and division between signed and unsigned integers in 2's complement systems is actually may produce different result and may be performed differently, I think. The only thing is the same is plus and minus, I mean addition and subtraction. So, but apart from that, you really want to separate them, I think. Signed. This is a very weird H, but yeah, this one is unsigned. So this is the hierarchy, but that hierarchy doesn't end here. So as an unsigned, you can have a value which is the instruction address, inst address, right? Instruction address. Then you may have a memory address. What am I doing for that? Address and the stack address. Stack address. So essentially the idea is the following. You shouldn't be able to do any operations between siblings of these types, right? You shouldn't be able to add, multiply, or divide, for example, instruction address by a memory address, right? But you can do these things between instruction address and unsigned address, right? So essentially, if you can climb up the hierarchy tree, you should be able to convert the types quite easily. But if you try to do these things between the siblings, they should be incompatible. So I want to introduce this kind of hierarchy at some point. We'll see how it goes. Maybe it's not gonna work at all. I don't have enough information to make an informed technical decision. So, and that's why I'm gonna just go ahead and implement this thing. And as I implement it, I'm gonna make mistakes, and this is how I gather the information, by the way. So yeah, this is how I gather the information. I just implement the thing, and then I have enough information, and then I refactor it to whatever I want it to do, actually, according to the information that I gathered. Basically making an informed technical decision. That's what I do. All right. Let's do this. So use kind, name, value, and binding should also inform technical decision. Yes, today is the topic of the stream. Theme of the stream, even. It's going to be an expression, and this is the expression that we need to evaluate. And when we evaluate that expression, it should be sort of cached into the value, right? It should be cached into the value that we can use. And some of the bindings may not be evaluated yet. So we need some sort of a boolean that indicates whether it was evaluated. Evaluated. So that should be it. And I wonder what's gonna happen. So what is this WM with the thin tabs up top? i3, yes, it is i3. You can actually check out my entire setup in FAQ. I think I have information there about what kind of software I use. Some things might be slightly outdated, but not too much. So expression, so I cannot access an expression from here, unfortunately. So yeah, it's down below. So what I have to do now, I need to take everything related to the expressions and move it up above, or at least maybe take the binding and move it down below the definitions of the expressions, right? The definitions of the expressions. All right, so let's try to recompile that and see if it fails. It doesn't even fail because I didn't really do any destructive changes, which is nice. So I remember that I had a function called bosom resolve binding, which resolves binding for me, right? It literally finds the binding and then I can use it for something. So far so good. Maybe I'm not gonna even try to change it, because what it does, it just returns the value of that binding. But I think, yeah, since the binding should be reevaluated when I'm taking the pointer to the binding, I want to modify it and claim that, all right, it was evaluated, so I actually need to return the pointer to the binding. I need to return the pointer to the binding. So that means I'll have to make this kind of change of the signature. So, and in here, this entire thing is going to be binding like this, and I'm going to just remove it. Okay, so this is a destructive change which will cause a lot of compilation errors, and this is exactly what I want, because I'm going to just go through all of them and try to fix them. Alright, so the first one is in the function itself. So now, instead of returning this, I just have to return yeah, I just have to return the pointer to the binding that I found. There we go. And otherwise I need to return the null. right? So, and that will be an indication that we couldn't find the binding with that specific name in here, right? So it's a simple function. You take the context of the assembly, you provide the name, and it should return you the binding with that exact name. And if it doesn't exist, it will give you null. And of course, you need to check whether it's null or not. So it's very important. Otherwise, you're gonna get a null pointer dereference. And who are you? A Java developer to get constantly null pointer dereferencing? No. So that didn't work for some reason. So return const qualifier from a pointer. Oh, that's very interesting. That's very interesting. Julien asked for UML. Excuse me, what is this? Okay, thank you. Thank you for making a UML diagram for that. Cool. So I think because of that, we'll have to change the const qualifier here. Right, so here's the const qualifier. And here are the places where we use this function. Okay, so we used to return it via the argument, but now we return it as it is now. So maybe I can do something like this. So this is going to be the pointer. I removed too much, then I'm going to take this entire thing and I'm going to do it like this. And if existing, yeah, that's exactly what I'm doing. It should be called existing. If existing exists, yeah, so if existing, that's actually pretty cool. Yeah, so it reads almost like English. It reads almost like English. I like it. Nice. So do we have anything else? Otherwise, we just increment bindings and we just append that to more bindings. All right, so that looks cool. Is there any other place where we need to do this kind of things? Yeah, so it's actually looks like pretty straightforward, right? So we just need to refactor it like this, right? Instead of passing it like that, I need to do it like that. And if binding equal null, so we say unknown binding, we provide the location, we know the location of the operand. So this is, by the way, the second pass compilation. The second pass compilation, that's okay. So it's actually quite important to have like two passes for the assembly, because we need to wait until all of the labels are known. So my balls usually get named like x is y if if x is y. And how do you define your booleans? Do you define them like this? Maybe that makes sense. If you want to make your code look like English, yeah. So that's a solution to that. Especially something like that would probably work in Adam as well. All right, so here's the binding, and we need to do something like this, right? And this one is going to be like this. And okay, so I think I'm done here. So I need to take a look at the rest of the compilation errors. Yep. Anything else? I think that's pretty cool. All right, so here is the resolving deferred entry. Oh, okay, resolve deferred entry points. So this one could be quite well. I mean, it's actually the same thing. Yeah. It's actually the same thing. So I'm gonna move this entire thing here. So in if binding equal to null, we say it's a known binding, and then we also want to check what kind of binding it is, right? Because in some certain context, bindings are of certain kind are prohibited. For example, if you define an entry point, the only binding that you can use there is a label, right? And this is why I want to introduce like a better type system where instead of like kinds of bindings, we would have types of expressions. And for example, I would be able to say, so you can only put an instruction address as an entry point, right? It doesn't make any sense to put a memory or stack address because you don't start execution from memory or the stack. you start execution from the section of the memory that is program instruction address, right? So you only can provide instruction address, but we can get there. We'll get there at some point. So right now we just have a notion of binding kinds. A notion of binding kinds. So here's the binding kind, and yeah, there we go. So hopefully that will compile now. I think I fixed everything. So this is the first step in establishing the feature. I also want to run the tests. Alrighty. So what essentially we did here is we moved bindings a little bit down below, and we changed the bosom resolve binding. So, and this will be very useful because I can resolve the binding, change something within the binding, and it will be visible for everyone who uses this function, right? So it used to actually return a copy of binding, which is kind of not really smart. Null Coffee. Hello, I haven't seen you before. Are you a new to this channel? My English is so horrible today. All right, so refactor bosom resolve binding. Okay, so, and I'm gonna push that right into the repo. So yeah, today we're working on our assembly, and we're adding more compile time feature, even though I think in assembly we don't have compilation phase, right? It's more of a translation phase. But to be fair, translating assembly is more complicated than probably translating CoffeeScript to JavaScript, but yet in translating CoffeeScript to JavaScript still called compilation, but in case of assembly it's called translation because of the historical reasons. I have seen your content on Haskell, otherwise new. Oh, I see. How did you like it? Did you like my Haskell content? Do you program in Haskell? Hello, bgot5797, welcome to the stream. Hello, hello, hello. Alright, so what's gonna be the next thing? So we can resolve the particular binding, but on top of that, I think we should be able to evaluate things. I never tried Haskell despite my dad's obsession with it. Oh yeah, Haskell is actually great for recreational programming, so people get very addicted to it, especially if you have a mathematical mindset, right? So you get addicted to this language pretty quick. So yeah, because you can basically develop everything in a declarative style, absolutely everything, not an imperative one, but rather a declarative one. I understood very little. Decided scene was a better entry point to functional programming. What is scene? I've never heard of it. It's yet another functional programming declarative scheme. Ah, okay, scheme. Just a scheme. It's more of a Lisp, but it's more of a pure functional Lisp. So yeah, it's a good introduction to functional programming. But scheme is a dynamic language, right? So you won't be able to appreciate the benefits of the statically typed compiled language. But anyway, maybe one day. Maybe one day you will. It's okay. So what I need to do, I need to find bm.h, and here is the bosom expression eval. Yeah, there we go. We don't have evaluation of a binding. If you try to evaluate the binding, it's not gonna really work well. So we found math at uni. Depends on the definition of math, to be fair, right? Because there are so many different branches of math that, and they're so different, they're so dramatically different. Like a person from one branch of mathematics may not understand the person from another branch of the mathematics. Set theory, yeah. So, and essentially, like, in my opinion, like, programming is math, but it's more of a discrete math. It's just people who argue that programming is not math, they don't really understand what is math. So they basically, for majority of people, math equals hard in school, right? If something is not hard, if something that is easy for them to understand, they just cannot believe that it's a math. Math, like the formal like education actually put the following statement in their brain: Math must be hard. If it's not hard, it's not a math. And that's why a lot of people, if you tell them that programming is math, they will argue, no, it's not math, I can do that. You see, I cannot do math, but I can do that, so that means it's not a math. But it's really, it's not how it works. It's not the definitions of the things. Yeah. So, and when people say that they hate math, well, math is too abstract and broad area, and how can you hate such an abstract and broad area? So you must be having something very specific in your mind and not the entire math, right? Yeah, so math classes is a completely different thing. Yes, those are bad, but yeah. Yeah, it's true. Yeah, it's true. So it's more about like, yeah, math classes. Just yeah, it's a kind of a separate thing. I've been watching for the last week, but now I'm curious. You are doing these projects on C because some concrete reason, or just because? Just because. All right. So let's start the evaluation of the binding. So the first thing we probably want to do when we are evaluating the binding, right? So probably want to actually keep this unreachable. So get into function programming because of symbolic logic. Math language programming made much more sense to me after taking that class. Okay. Then you code segfaults and you're like, oh yeah, it does that. To be fair, segfaulting is not the most difficult problem in C, because usually the debugger will tell you where exactly it segfaults, right? So you can do something like, you know, int null, and you just literally dereference this entire thing, and that will segfault 100%. But then, at any point, you can just go to the debugger and just look at that place. We can even take a look at that, I think. So let me see. It's going past the end of a race. Oh yeah, that's a classic thing. That's a very classic thing. Alright, so let me try to run this entire stuff so it doesn't even compile properly, because I need to dereference this, of course. Of course, I need to dereference all of this. Okay, and we have a signal 11. I probably have to update my null build. So build bin bosom, so it's segfaults GDB, and then I try to run it, and it tells me exactly where it's segfaulted. Furthermore, it even tells me like the stack frame. I can even take a look at the source code and clearly see where it's segfaulted. So it's as bad as null pointer exception in Java, where you get the whole stack trace. Yeah, null pointer exception, but you get the place where it happened. But so the problem may be if null pointer exception happened because somebody put null here and it was put in a different place. In that case, you can actually have data breakpoints. Essentially, you can say basically break when somebody modifies this thing and sets it to null. And in that case, you can easily quickly find the place where somebody sets the null to that particular thing, and then quickly find a place where that happens. So that's a little bit, you know, worse, but, you know, fixable. In my opinion, the most brutal situation in C is a stack corruption. If you manage to corrupt your stack, well, pack your things, seriously. Nothing will make sense. Nothing will help you. Nothing will work. It's just delete your project and start over. Like, it's, yeah. If you corrupted stack, goodbye. So, in my opinion, segfault is actually not that bad. Usually you can do something about it. Yeah, so exactly. Nothing makes sense, absolutely. It just goes crazy. How can you break your stack? Maybe you're doing some funky stuff with variadics, I guess, because variadics, like, the store their arguments on the stack, and you use special magical types to iterate through these elements on the stack, and it also modifies the stack. And if you do that not according to the protocol that C established to you, you may corrupt the stack. Maybe some other stuff, like, yeah. There's so many ways to actually corrupt the stack. Yeah, also put an array in the stack and just overflow it, and it will just overwrite everything on your stack. So yeah, it's fun. C is fun. I also started learning C on OS X because it does not support GDB. Needed to SSH into school machine and run all my code there. You don't have GDB on OS X, but do you have any other debugger? It's really strange. I cannot believe that. GDB even works on FreeBSD, does it not? So, well, I mean, I never used OS X, to be fair. I never used any Apple products in my entire life because I'm too poor to buy them. So, yeah, I have no idea how things work there. Anyway, well, LLDB should work definitely. Yes, LLDB should definitely work there. How did you choose this time of the streams? I just chose it according to my schedule, my sleep schedule. Are you more productive in the evening or just for the viewer's time zone? I don't know when I'm productive. I don't know. I just chose it according to my sleeping schedule. So I woke up around 1 p.m. to be fair, and at 5 p.m. I start streaming because that's enough time for me to, make a breakfast, do all the chores and stuff like that, and then I just stream, and that's it. That's my day, every day. It's kind of sad, but it is what it is. Yeah. Cheers, I suppose. Dream life, I guess. Anyways. Okay, so we need to evaluate the binding. So to evaluate the binding, you need to think like a binding. You need to become the binding. Yes. All right, so we need to query the binding first. We need to use bosom resolve binding, right? And we already have a bosom context, and we probably already have the name. And it's gonna be there, expr value as binding. There we go. So that should give us binding like this. So, and if binding for some reason became a null, we need to report an error. What we're gonna report there? std error. So first of all, we need to know the location of an error. So maybe we're gonna pass the location via argument here. I think that makes sense. And this is how we're gonna use it: fl fmt, then error, I think like this, and then fl arg location. Oh yeah, maybe some people don't know, but I have developed a pretty interesting way of printfing custom types. For example, imagine that I have a type called string view, right? It's a pretty simple type. It's like a sized string, a size immutable string. So it stores its size and a pointer to the beginning of the memory. But I also want to be able to printf from time to time, right? And for that, I developed a special macros. So sfmt is defined like this, and svarg defined like this. Basically, it takes the structure and then packs it into the arguments. So the way you use it, you basically use it like inline. You put svfmt in the place where you want to print thing, and then you wrap your structure in svarg, and it unpacks it into several arguments needed for the format to actually print it correctly. because I was just using them, and it has FMT macro that looks the same FMT. Oh, interesting. But yeah, essentially it's just because in C something like this, right, is a single string literal. As far as I know, this is a single string literal, which is equivalent to this. It's literally equivalent to this. So basically, it concatenates the string literals like that if they're just separated with spaces or, you know, like separate tokens, right? And that means if you have a string literal like this, you should be able to do the following thing. Hello SV FMT world, and that is essentially equivalent to hello S world. So this is how C works. So the specifics of how C works with the string literals allows you to do this kind of stuff. Right, and yeah, you can actually have more complex types defined. For example, you may have a 3D vector, right? So imagine that you have a 3D vector which has x, y, z as floats, and you want to define, you want to be able to easily print f those vectors, right? So you define a special macro v3 fmt, and that macro is going to consist of the following thing: f, f, f. There we go. So here's your fmt macro, and v3 arg should basically accept the vector and then unpack it for the printf. So it's going to do v3x, v3y, v3z. And now if you want to print, for example, a position, right? You have a position, you do it like this: v3 fmt and then v3 arg, v3, right? And yeah, so, and basically you don't clutter your printfs anymore. You have one thing in the position you want to print the type, and one thing in the arguments that's supposed to provide the data for this thing. I used to just write, yeah, it might also work, but here's a cool thing. This works with the sendprintf too. So the problem with print functions is that you have to have a separate function that prints it into the string, but this also works. So, and of course, there are some limitations, right? Maybe like it only works for simple types that can be just unpacked, right? Unpacked. But if you have a type that needs like recursive traversal to be printed, like that might be difficult with this approach. So it works relatively well for simple types. So yeah, so it's pretty cool, but it has its own limitations. Oh yeah, for example, you can go even cooler than that, I think. So imagine imagine that you have a caller defined as 32-bit integer, right? You have a caller defined as a 32-bit integer, and you basically want to print it as you know, as its RGB components, right? You want to print it as its RGB components. So you would define something like caller, let's call it caller FMT, right? And let's put something like this. It could be 02x for R, 02xb, 02xc, and so on and so forth. And then you can define caller arg, where you're gonna take your caller and using bit magic, right? Bit magic, you're gonna extract each individual component out of this thing, right? So it's gonna be how many, 8, and then take another one, and so on and so forth. So it doesn't necessarily has to be a structure, yeah, right? So because you may apply like additional operations and so on and so forth, and it's just an integer. It just unpacks your integer into these arguments. So yeah, and the thing I'm surprised about, why this approach is not a thing in libc. Like, I mean, yes, it has its limitations, but I mean, for a lot of cases, it's cool, it works, and it's pretty pleasant to work with. So yeah, and I have a type called file location, right? File location, and for a file location, so it consists of a file path and a line number. So what it does, it basically prints the file location as file name.c colon line number, and this is compatible with a lot of parsing tools that parse compiler errors, right? For example, in Emacs, if you have a compilation error, right, and you run compilation from within Emacs, it understands this format and lets you actually jump there. So essentially, I print things in the same format so I can easily catch them in Emacs as well. Brains like you can't define things without putting parentheses around them. It's not allowed. yeah, but in fact it is allowed. It's not allowed because people usually quite easily make mistakes. But yeah, if we start thinking outside of the box, we can do pretty cool things. Yeah. So I call these kind of macros as unpacking macros because they're kind of similar to argument unpacking in C++, right? In C++ there are such things as variadic templates, and basically they allow you to have like packs that you can then unpack, and they're kind of similar to what you do in C with these macros, right? So yeah, I guess maybe. Alright then. Okay, so let me continue with this kind of stuff. Alright, so here's the file location, and I think I need to update this function signature because it also needs to take file location. Oh yeah, maybe like Python, yeah, so it's similar to Python. Python has like a very complicated syntax for keyword arguments and stuff like that. You can have like small DSLs based on keyword arguments and whatnot. What language? I think it was JavaScript. I think... Wait, it's Perl! Wasn't it Perl? Or maybe PHP. Oh yeah, explode. Yeah, PHP has explode, but it's not unpacking, it's actually splitting a string by a delimiter. It's not really like unpacking, but it's just like, why did they call it explode? I don't know. So maybe because it allocates a lot of memory. That's why. I don't know. Alright, so, and every time we call to Basm expert eval, we need to provide the location where this kind of stuff happened. So translate bind directive. So, we're evaluating it, and I can provide the location. Okay, so I can just use the location that's provided here. Expose the CPU. Oh, JavaScript has sprites. Okay, yeah, interesting. Okay, so this is within the translation, so we always have a location there, so it should be okay. Alright, so file error, file location, could not find binding, and I can just put think like this, sv fmt, and now I just have file location and sv.arg, and the name is, I can probably extract that to a separate variable here, string view name, yeah, there we go. So could not find binding, and it also properly reports the location, which is quite useful, and then we can execute one. So I don't have any fancy like recovery from this kind of errors, right? At least right now. So I just crashed the whole thing. I think it's just easier to handle. Control reaches the exit. It's really... Okay, so maybe I can just return 0 for now. Word 64.0 because I want to try to compile it. Okay. Now, so once I'm evaluating the binding, I can take a look whether the binding is already evaluated, right? So according to the definition of binding, evaluated, if it's evaluated, right, I can just return the value within the binding. just the value within the binding. If it's not, well, I need to recursively evaluate this entire thing. And this is where it's going to be super dangerous. So it's going to be bosom expression evaluate. Bosom. An expression is the expression within the binding, and we also provide the location. Okay, so that will return the value that we probably want to cache back, right? So we evaluated this thing, and we're doing binding value equal to that value, and we also say that this particular binding is evaluated. There we go. And only then we can try to return the value. To be fair, since we're returning the binding value in both of the branches, we can probably do that somewhere here. And basically just do not evaluate it, and there we go. So if binding is not evaluated, we are evaluating it, then caching it back, marking that it was evaluated, so it's not going to be evaluated yet again. And there you go. So that should actually work if you think about it. That should just work. Did you give out on Prolog compiler? I kinda did, so it was just an interesting, fun idea. But I don't know, not really that interested in Prolog. Alrighty. Alrighty. Typo? Probably. Whatever. So now, so let me see where we use this thing. So instructions. So this is for the instructions. If we encounter a binding, we defer it, but if it's not a binding, so okay, that's cool. Bosom expression eval. Oh yeah, there we go. So translate binding directive. So bindings cannot be dependent on other bindings, yet we're working on it. Yes, I think the time has come to actually remove this entire thing. Because it's not true. So now bosom expr eval can be used here like that. So we parse the expression, right? Then we evaluate the expression, and then we bind. But do we really need to evaluate it? I'm thinking. Do we really need to evaluate it? No, we don't have to evaluate it. Translate bind directive. So yeah, we evaluated it right away, but we don't. Since we're starting to make them depend on each other, we shouldn't do that. We definitely shouldn't do that. So bind value. And when you bind the value, you shouldn't provide the value, you should actually provide an expression. Okay, that makes a lot of sense. Okay, bye-bye, Esther. We've got ahead of... okay, sure, bye-bye. See you around. So, let's make a cup of tea then, I suppose. I haven't made a cup of tea for quite some time. Whew. So, yeah, compile time evaluation, very exciting. So, what are you guys drinking while watching this stream? I hope it's not too loud. Hi there. What are you working on? I'm working on a virtual machine with its own bytecode and assembly for the bytecode. And what's cool is that this assembly also has compile time evaluation. And that's exactly what I'm working on. I'm implementing compile time evaluation for the assembly for the bytecode of my virtual machine written in C. Does it make sense? And you can find the source code here. So if you type today command, like exclamation mark today, you will get the source code to the thing that I'm making. So it contains it has the whole tool chain and some examples on how to write for this virtual machine and so on and so forth. So I guess it's kind of difficult to elevator pitch this particular project, right? Because it's a virtual machine, but it's not just virtual machine, it's also a language on top of the virtual machine. But it's not just assembly, it's a very interesting assembly with compile time evaluation that is better than macro system of any assembly, in my opinion. At least I will try to make it better than the macro system of any existing assembly. Cinnamon tea, drinking for breakfast now with the Captain Saturn. Sounds like a complicated project. Not really. It only sounds like a complicated project. In reality, it's only 2,000 lines of code. It's actually pretty small, as you can see. And it's only one header, right? Well, right. We actually have several of them, right? So we can try to take a look at some stuff. Clock. It's like 8,000 lines of code. Yes. Oh, probably not true. So we have a build tool, a build folder with a lot of shit. I think we can actually get rid of that. Yeah, it's like 4,000 lines of code. Not that big. Will you ever let your hair grow again? Maybe, I don't know. So right now, if I let my hair grow again, at some point it will be very difficult for me to shave. So the amount of time it took for me to shave for the first time was 3 hours. I spent 3 hours doing that. I don't want to spend 3 hours again. And that will mean that I'll have to go to the hairdresser. And I just don't want to do that. So yeah. Since you seem to be taking a break, if I revisited your material in Haskell, what would you suggest I try to get out of it? Try to have fun. All right. Alright, so okay, I'm gonna go to the kitchen and turn on the kettle, and then I'm gonna be back super quick. Hopefully, I don't know. I don't know what kind of adventures await me. Don't go alone. It is dangerous to go alone. Take this. So, what I was doing, by the way, I don't freaking know. This is definitely not what I wanted to do. So let's try to rebuild the entire thing with the tests and stuff. Tests and stuff. It's like your hots and plots, but tests and stuff. I'm sorry, it's so bad. Alright, so now, when I'm trying to bind a value, right? So bosom bind value, I think we should try to postpone the execution. So we're trying to actually bind a word, but what we should be actually binding there is an expression. See? We should be binding an expression. And let's make this kind of change everywhere. So we're not binding the actual value, we're binding the expression. Exp. God freaking damn it, okay. Export. Sometimes it feels like the Emacs lagging behind or something. That's what it feels like sometimes, and that's why I have this like trailing A's all the time. It's just so weird. Maybe I should stop using Emacs. And Emacs works really bad with big files like this. It just like cannot handle any of that. So yeah, maybe the time has come, chat. I think, well, yeah, for Emacs this is a big file. It's not really for Emacs per se, it's for CMod. So CMod is notorious for being slow with this kind of, you know, files. Goose who's back to back. Hello, welcome back, Avni. The old advice used to be, no, it's not even with Linum mod, seriously. And this is not a Linum mod, by the way. Use Qt Creator. That's actually not a bad idea. Do I have a Qt Creator? Yes, I do. Okay. Look how slow it runs. Oh my god, it's beautiful. I love it. It's slower than Emacs. White Theme Gang. Certified by Andrew Skunk, yes, exactly. Can I open shit in it? Zozin, BM. Oh shit, I just realized I want to pee. Fuck. This file is not part of any project. The code model might have issues to parse this file properly. Okay, can I go to the dark theme gang, please? I appreciate the white theme gang, but... environment, user interface, color, theme flat, dark. Dork. What year is it? What year is it, I ask? Okay, sure. Classic. Open whole folder instead. Okay. Oh shit, that's cool. VS Code is slow as fuck. Holy shit, I tried it as well. It's very slow. It's slower than Emacs. It didn't work. Okay, I'm gonna use Vim then. Zozin, use that favorite thing I use every day, because that's the only thing you need. Because I use it. Okay, so we're gonna use Vim. Oh shit, and it's actually very difficult to jump between the errors and Vim. Yeah. And the only thing I will be able to use is probably CM. Right, while I'm doing this kind of stuff. Let's give it a try. Okay, yeah, there we go. So I'll have to use CM. And CM, I probably wanna actually... Yeah, I wanna use GVim then. Yeah, is it possible to use GVim? I think it should be possible to use GVim. Okay, so that's more or less, yeah, but it takes some time to actually all that. So value undefined. Okay, so here's what we have here. Right, so here's what we have. So BASM name expression, and when I'm doing an expression, right, I'm setting a value, but now I should set an expression. Right, so I'm setting the expression. So what's that? Incompatible type of the argument, so this is a value. There we go, this is what I'm talking about. So instead of doing that, we have to put an expression there. And do we have anything else here? So translate. Oh, that's very interesting. Sodium chicken? Vim has a terminal built in. You can probably run CM in it and make it jump to error that way. I didn't think so. I actually doubt I can. So I don't remember. Is it just term? All right. Wait a second, really? Okay, that's probably cool. Oh shit, it's actually... I cannot do Control W because Control W switches the focus. Okay. So no build, right? Okay, so here's a no build, and I'm gonna try to run no build here. And Alt J doesn't. Okay, so there's so many. Oh my! Nothing. Yeah, it's completely broken. It's completely broken. Nothing works. Nothing works. Emacs setup would be perfect. Emacs setup would be perfect if CMod wasn't that slow. CMod kind of ruins everything. So to the point that maybe it's easier for me to just use Emacs without highlighting for C files. Oh yeah, I think I already demoed that several times. I think I already demoed that. Look, look, look. But now, if I switch to text mode, it's not Emacs, it's CMod. CMod is slow as fuck. Emacs is actually by itself capable of a lot of shit. I managed to like work with half of a gigabyte, like 500 megabyte log files quite comfortable in Emacs. Oh yeah, I had my own, yeah, I had the idea actually. I had the idea of developing my own C mode that is very simplistic, like it contains only bare minimum and doesn't try to be smartass about things. But I think I never actually finished it, so yeah. I think it was simp C mode. Yeah, simple C mode. Yeah, I never finished it in its cold source. So I wonder if it still works. Alright. Bent 2S C mode. Yeah, so we should. Yeah, essentially just takes like keywords and just some fonts and stuff, and it also tries to do like a basic indentation, but actually getting like a basic indentation is still hard in C. So yeah, let me actually take a look. Zozin simp, I think it's Rexim simp C. Yeah, there we go, here it is, it's still there. So I'm gonna eval the buffer, and then I'm gonna go to BM, and I'm gonna enable simp C mod, and it seems to be working, right? And let's take a look. There we go. It works nicely. So the idea is that, but the problem is that it's like indentation doesn't really work correctly. Indentation doesn't work correctly. You know what? I'm gonna actually open source this entire thing. I was trying to keep it private because I wasn't sure if I ever gonna finish or whether it's gonna be successful. But I think rewriting C mod from scratch and making it super simple and just removing all of the bullshit from C mode is very beneficial for, I don't know, for Emacs community, maybe not for Emacs community, because I'm not sure how many people in Emacs community still program in C. But I'm pretty sure it's going to be beneficial for people, for the community of Emacs C developers. I don't know where I'm going with all that, whatever. So, settings. Join us now and share your software. You'll be free, hackers. You'll be free. Free. Join us now and share your software. Alright, so I understand change. There we go. Okay. Leaked! Ah! Leaked! Ah! So there you go. I'm not sure if it's interesting for anyone, but we can try to use this for a while, and maybe, yeah. So what I'm thinking is that maybe I'm not gonna have any particular indentation. Well, yeah, there is some indentation here. Password 123 yes, you guessed it. You guessed it right, my friend. All right. So it doesn't even highlight Boolean, but I'm not sure if I need to highlight Boolean, to be fair. I'm just highlighting special characters and whatnot. So far, so good. So far, so good. Download, try. Heck. Who needs boolean? Just use int. Well, yeah, sure. I mean, in C. I'm liking the context. I'm sorry. I don't know why I'm commenting that at all. Okay, so incompatible type with the argument. So essentially now I should be able to create a new binding there. You know what? I have an idea. Since we're gonna have expressions, let's at some point introduce function calls into the expressions and finally implement the ability to do something like push len of hello. You know what I mean? Right, so essentially you're gonna have like compile time functions within Bosom, but they're gonna be predefined for you, right? So something like taking the length of the string or something like that, right? So something to compute expressions. Does that make sense? Hopefully that makes sense. Holy shit, like it's so pleasant to work with SimpC, believe it or not. Like it's just pleasant to work with. Like it's so fast. Like, and I don't really notice that much of a difference in functionality. I wasn't even using any of the features like of C or anything. Like, it's so fast. Okay, so the problem is that like C mod makes it feel like Emacs is slow. Emacs is not really slow actually. It's C mod. It's just garbage. So yeah, we need to rewrite C mod. So, and if you have any suggestions on, you know, SimpC mod, feel free to submit pull requests, issues, and stuff like that. Let's just write a better C mod. Not really better, but the one that will at least let you work with big C files. But why is it slow? It's just, I can ask that question to, like, about any software in 2021, essentially. Like, why is it slow? I don't know. As Belginul said on our Discord, rendering HTML is harder problem than streaming full HD video overseas, right? So the question is, why should it be more difficult? I don't know, it is what it is. Welcome to modern software development. It doesn't have to be. Emacs is actually like can work with very big files easily, unless there's some bullshit extension that actually prevents it from doing that. Oh, it's so fucking pleasant. Oh my god. Like navigating in SimpC mode is like rubbing my bald head. It just feels so nice. I'm sorry. Okay, do you have a regular job? No, I have a irregular job. Or you plan to sell what you're making here? I'm already selling it. I'm making content out of it, and people buy it. So yeah, people like it as well. That's how it works on Twitch. On top of that, when I'm not making content out of this project, I actually do it just for fun. It's my pet project. So, yeah. Would you urge programming to become streamers? No. Why? The goal that CC mode shouldn't be overly slow, take more than a fraction of a second. 10 is also a fraction. Oh, it's you. I'm just thinking, why do you ask such a weird question? It's you, Sent as well. Welcome, by the way. Haven't seen you in a while. How are you doing? No one watches programming on Twitch. Yeah. Classical Zen 12 question. Thank you. Thank you so much. All right. So I swear to God, Zen 12, I can recognize you under any nickname by your questions. Seriously. I'm saying your questions are the best. I really like your questions. Thank you so much for asking them. It's just it's beautiful. They're absolutely beautiful. All right. So essentially, what I want to do, I want to remove this shit, and basically make it to do. Why is it? Oh my! It's so fast. Like I cannot get over the fact how fast it is now. Oh my god. So there is no way to get the length of this string again. I removed it. Oops. Nice description, by the way. Those in PeopleRef and people. When you post a link to them in the chat, font locking can be super hook, especially the font locking done on decoration level 3, which tries to be very accurate. I don't know. Alright. So, oops. Oh, okay. So A was not caused by the thingy, by the slowness. Very well done. So label binding, and what are we binding here? We're binding the program size. Oh, all right. So I need to create a new expression then. How can I create a new expression? Well, I guess I can do something like. So let's put it as an expression here. Oh, now it's going to be applicable to like everything. Okay. Expert. Where is my expert chat? It's kind. Okay, so it's kind. Equal to expert. Actually, expert kind. And what kind of it is? Is it a binding? Is it lit char? I think it's just int. Okay, and then I can do a value, and the value itself has to be as u64, or maybe as lit int. Yeah, as lit int. So this is what we're gonna have here. But to be fair, maybe there should be. We should separate functions bind value and bind expression. Bind value will bind evaluated expression, and bind expression will bind the deferred expression that will be calculated later. Let me take a look at your emotes, and I'm gonna be the judge whether they're good or not. I'm gonna be the judge of them, okay? Okay, could have been better. I would say it's an average tier emotes, like an average tier. Nothing particularly fancy. Could be interesting for a couple of days. Yeah. So I edited them. All right. So reload channel emotes. There we go. Reload channel emotes. Cool. So we need to separate the notion of adding a binding and adding the expression. Alrighty. So bosom bind value. Right. So, and because of that, this thing should be called bind expression. Right. You bind in an expression. But at the same time, bosom bind. We need to introduce bosom bind value. That's quite important. So instead of this thing, it's going to have value. Bosom bind expression. Let's put this thing here. And it's going to be actually pretty similar to what we already have, except it's not going to mark thing as unevaluated. It will evaluate it automatically. So first of all, we want to assert the dominance inside of the body of the function. Binding size. Bosom binding. Why am I saying binding? I mean, what the hell is wrong with my English today? All right. So binding existing. All right. Bosom resolve binding. Resolve binding is going to be bosom name. Right. It's a bosom name. And if it already exists, existing, we're going to report the same error here. Right. We're going to report the same error, saying that this thing already exists. Sorry. But now, when we add this thing here, I'm gonna add value equal to value, and then I'm gonna say evaluated equal to true. So it's automatically evaluated. You don't have to do anything about that. You don't have to do anything about that. Hey there, what are we coding here? We're coding a virtual machine in C. There we go. Take a look at that. So this is the source code of the project we're currently working on. Bet you didn't expect that shit to happen. The Tsoding channel is full of surprises. Am I right? It's full of surprises. I surprise myself every day. Hello, Unscripted Logic. Welcome to the stream. Let me guess. What are we coding today? What are we coding today? So I'm gonna put a value here and okay. All right. So oh yeah, I see. So this thing should be less like this. I heard it. Okay. Nice one. I really appreciate you. Thank you so much. Okay. And we fucked up. Yay! Yay! I'm so happy. We fucked up. So, yeah, I wonder where exactly we fucked up. So, yeah, should be pretty straightforward, like it should already work. We evaluate everything recursively. Then, okay. So I'm gonna create a simple example. Right, it's gonna be test bosom. Right, test bosom. What does it do? It's going to define a constant a, and it's going to be equal to 69, right? And then I'm going to just push a to the stack, and then I'm going to hold, right? And then I'm going to say the entry point is going to be main. There we go. Very simple program. Let's try to compile it. So I'm going to use build bin bosom, and I'm going to provide test. I forgot to save everything, of course. Build bin bosom, and the input is going to be test bosom. And the output is going to be test BM. Cool. And now if I try to disassembly this entire thing, what will I see? It's going to be dbosom. Right, it's going to be dbosom. And, excuse me. Yes, it didn't resolve the label. It didn't resolve the expression. That is very interesting. The question is why? Just started learning coding ago, so this looks like an eyesore to me, OMG. Okay. Cool. So something does not really resolve really well on the second iteration, right? We do the second iteration and it doesn't really resolve well for some reason. Where is our second iteration? Maybe we're gonna put a breakpoint here and just see what's gonna happen. So what do you guys think? Do you guys like Debugger Wagga? Before I go Debugger Wagga, I really wanna pee. So simp c. I don't have a simp c mode. Oh shit, every time I restart Emacs I have to go to SimpC mode, re-evaluate everything, then go here and then enable SimpC mode, and that should work essentially. Alright, so let's make a small break, by the way. Small break. There we go. It's gonna be how many minutes? I think it's 2 minutes gonna be. Yeah. By the way, I'm using my, I forgot the name, snippet. So now I can do SB 2 minutes. Boom. How about that? Can you Vim do that? So, and at any point, if I want to, for example, do 69 minutes, boom. And I don't have to realign anything, right? I only have to adjust the stuff and yeah. And then SB 2 seconds. And there we go. Alrighty, so, boys and girls, let's make a small break and you guys have fun.
Три Монтас Пакдерас.
I'm back. Thank you, Just Roxy, also for 3 months. Thank you, and welcome to our epic virtual machine club. How about that? Thank you. All right, so so what do we have? I want you to do the debugging. So second pass. Okay, so let's go to the second pass, and it's gonna be. Maybe I also want to rebuild everything. I'm not gonna test because tests hang, but we definitely need to rebuild everything. That's very cool. So I'm gonna run bin bosom, and the input is gonna be, I suppose, the example Fibonacci example, and the output is gonna be this thing. Okay, and yeah, we confirm that this doesn't particularly work, right? So because it produces the incorrect thing. Oh yeah, wait. I have to use the test bosom. Yeah, I have to use test bosom, test bm, right? And then if I do dbosom on this thing, dbosom, it produces 0, but it has to produce like 69. I see. So now I'm gonna do GDB. I'm gonna remove that, and I'm gonna break on bm.h, and the line is gonna be 1730, right? And we're gonna run, providing test bosom and the output as test bm. The output is gonna be test bm, and let's see what's gonna happen. Okay. So what do we have here? So the first thing, the first deferred operand, let's take a look at the expression there. So the expression is a binding, and as a binding, it has a one single thing here, which is binding A, right? It's in fact a binding, and then I extract the name of it, and if I print the name of it, it is in fact a binding. Right, so then I try to extract the binding from this entire thing, and it does contain something. Okay, so we found the corresponding binding. Oh yeah, I see. And the binding was not evaluated, right? Let me guess, it's not evaluated. right? Maybe I have to do it slightly differently, right? Evaluated. It's not evaluated and its value is 0 because it was never actually forced to be evaluated. Okay, that makes sense now. So, and that was needed because we didn't have like binding evaluation situation. All right, so I'm really glad that I decided to pull off the debugger because that kind of helped me to understand the situation. All right. That's pretty cool. So we're resolving the binding, and maybe I need to be able to force evaluation of the binding, I think. So where is the binding thingy? Where is the binding type? What if I had something like binding evaluate? All right, and I'm gonna accept the pointer to the binding. I'm gonna set the pointer to the binding. And to be fair, evaluating binding also involves taking the pointer to the context, so you won't be able to do that without the context, so we'll have to do that here as well. So this is a pretty important function here, binding evaluate. So, and then we're gonna have bosom eval expression. So it's almost like eval expression, but more specific for the bindings. I wish I could find, it's expression eval, bosom expression eval. Bottom expression eval, and I'm gonna literally just move this entire code there. I'm gonna literally move this entire code there. Chat, why are you dead? So tell me something. Why are you dying? So here's the name. So then expression. We already resolved the bindings, so we don't need to do that anymore. Something. Thank you so much. I really appreciate it. Okay. Trust me, chat. Once this feature is implemented, it's gonna be so fucking goddamn epic. Because you will be able to do compile time evaluation and, you know, have more control over the compile time of the translation. Alright. So we resolve this entire thing. If you couldn't find... Oh yeah, this one also requires the location. What's up, Kurzipskugabits? Thank you for joining the stream. I really appreciate your nickname. Hello, hello. File location, so it's gonna be a location. So this one is kind of interesting. Oh my god, it's so far away. It is so far away. Kingslayer, oh my god, hello, hello Kingslayer. Welcome to the streams. Welcome, welcome, welcome. I'm just waiting for my paint to start up. Did I run my paint? I think I ran my paint. Where is my paint? Okay, thank you very much. So, hello Lazy Grid. Welcome to the stream. So bindings are essentially an array. So we have an array of bindings. These are bindings. Oh my god. It's a permaban. Sorry. Ban flooring mother. And I wish I could just clean the chat, but maybe not. I'm gonna keep the chat like this. Yeah, classic. Classic. Binding. Binding. So, maybe, yeah, let's actually put the follower modes. I forgot that we can put the followers mode. Let's say 1 hour. I think it's gonna be okay. So can you chat? I can clean the chat, but it's not gonna work. Can you guys spam a little bit so it scrolls up? Just spam a little bit and it's gonna be okay. All right. Thank you so much. Okay, so we can bring we can bring it back. Cool. We can bring it back. Also, we have a follower mode, so it doesn't matter anymore. Hello, hello. Now, so this is like we have an array of these things, and then we also have expressions, right? We also have expressions. So an expression is just like this AST, something like that, right? And so on and so forth. So we have something like this. And what's funny is that one of these like values can be a binding too, right? So these kind of things can refer to other bindings and whatnot. And essentially, when you're trying to evaluate a particular binding, you're starting like going through this graph of things that depend on each other. So this is basically what's going on here. So, and binding C. There we go. Binding C. Alright. Yeah, and that's essentially what I do. So the function binding evaluate, right? It accepts the pointer to a very specific binding, right? So it accepts the pointer, and what it does, it just triggers the chain of evaluating everything, right? And every time you evaluate the binding, it also caches this value, and so on and so forth. I just wanted to explain what I'm doing. So maybe it's useful. All right. Alrighty. So yeah, and that's why I have this particular function, right? So it accepts a pointer to the binding and it triggers this entire chain of the thing. Make sense? Make sense? Should have probably yeah. Here's the image. So and to do that, network of bindings, more of a graph. Right, we usually call these kind of things graphs. So yeah. All right. We usually call them graphs, and I query the binding. Do I need to query it? So I already. Yeah. So. I don't need this thing here. Right, first I query the binding, then if I couldn't find it, I do this kind of thing, and then I can do binding evaluate. Right, I'm trying to evaluate that specific binding. Trying to evaluate it. And to be fair, do I need a location of it? Yeah, I do need a location of it. Right, so it's going to be binding, also bosom. And then location. Cool. So now I have a special function, and at any point, if I have a pointer to the binding and I want to force evaluation of that binding, I can easily do that, and it checks whether it was already evaluated and not, and now we can use that. So now I go to the second pass compiler. Right, I found the binding, and instead of resolving the binding myself and directly using its operand, so what I have to do, so yeah, now it's kind of dangerous to directly using the value, right? You shouldn't directly use the value. So now we have to do binding evaluate, where you provide like bosom, and then you have to provide the pointer to the binding itself, and maybe the location. But the question is, where is the location? I think location is this. So yeah, it's a location of a deferred operation, and I wonder why don't we have it here, for example. So file location, so I can just do it like that, and so then later I can provide the location here, so it reports everything appropriately. And we'll probably have to do a similar thing here. So as you can see, I resolve a binding, then Assign the value. Yeah, it's very dangerous to do it like that. You shouldn't never do that. You should never do that. So, and it's kind of cool that I managed to quickly catch this bug. Right, so here is the bosom, then binding, and then location. And do we have a location? It's actually entry location in bosom. Yeah, it's bosom, entry location. Cool. And now if I try to compile this entire thing, right, if I try to compile it, all right, so evaluation bosom, unknown type bosom. Okay, so let me find the type bosom. So I'm gonna define this array here. Maybe I should actually rename it to something else. We'll see. Too many arguments. Well, don't you have to provide the location there? I think you have to provide the location there. Excuse me, binding evaluate, you have to provide the location. The file location is quite important. Okay, incompatible type with the int address. Okay, so then I can do as u64. So just interpret it as u64, and I think I managed to do that. I think I managed to do that, chat. We freaking did it. So let's test everything and just make sure that I didn't break anything. Will the test pass? No u64. Okay. Yes. You know what? I want to rename this this function. So we're gonna test it soon. Don't worry about it. Binding evaluation. So where is the eval? I'm gonna put this thing here. So, and it's gonna be like 10 and whatnot, and it's gonna be 9. So I want to rename this entire thing to bosom binding eval. That's what's going to be called, bosom binding eval. So you're not evaluating an expression, you're actually evaluating the specific binding. All right, so, and that makes a lot of sense. Oh my god, this makes so much fucking sense. Holy shit, I like it. So all of the types, they just come together like, you know, like a Billy Harrington. And Van, sorry. So that pasta actually affected me, so that's why I'm starting to like an orgy, yeah. You know, Emacs orgy mode. So that's the effect of that dick pasta that has on me. Yeah, I still remember. Can't forget it. Can't forget it. I'm really sorry that I had to ban you. You're violating TOS, but yeah. I wish I was streaming on a website where this kind of stuff was, you know, allowed, but unfortunately, sorry. Maybe next time. Maybe on a Chaturbate. Let's see. All right. So. Let me see, so it's gonna be test, bosom, stream on Chaturbate. I cannot stream on Chaturbate because I have a contract with Twitch. Okay, if I ever get banned on Twitch, right, permaban, I'm gonna do a Chaturbate stream. I'm not even joking, I'm gonna stream on Chaturbate, but I'm gonna stream programming. Not everyone knows, but the rules of Chaturbate, as far as I know, they do not forbid you to stream programming there. So, yeah, you can stream programming there. Like, I remember some people just did like just chatting stream on Chaturbate, and it was fine. So, and I remember that some streamer reported that the viewers were nice, the viewers were understanding, right? So they didn't force anyone to, you know, do all this stuff. You can get your banned, no worries. Thank you so much. Just do it naked. Well, I'm already naked underneath my clothing, so yeah. Does it count? Hopefully. Anyway. Yes, I know. I'm very smart. Viewers on Chaturbate more mature than Twitch. True. True. You know why? Because they have money, right? So they have money, so that means they have job, that means they are more mature audience, right? At least those who write in chats, right? I don't know. Too bad I have contract on Twitch, otherwise I would definitely stream there. 177. Okay. Oh, before we actually go commit everything, I want to do a test. So chat, look. It's gonna be fucking epic. So test bosom. Right. I'm gonna define test bosom. I'm gonna define a constant 65. Right. Then we're gonna have A, B, A. You cannot do it like that. Okay, let's do 69. Let's do 69, and it's gonna be like this. So the idea is gonna be the following. I'm gonna push A, and I'm gonna push B. Both of them have to be. Both of them have to be 69, right? Because the value of you know, B is equal to A. So let's just wait. How many seconds it will take for, you know, fresh grads, CS fresh guys to say, but what if you make it cyclic? 1, 2, 3. CS fresh grads, where are you? Where's your... But what if you cycle them? Come on, don't be shy. Ask this question. I know that you want to ask this question. Come on. Okay. Oh, they're busy filing exams. Okay, that makes sense. Sure. Okay, so let's try to compile this entire thing. Bosom, test, bosom, test BM. Cool. It didn't crash at least. So now I want to try to debosom this entire thing. Bin debosom, and it's going to be test BM. And look at that. It actually resolved all of them correctly. Okay, so let's do the thing that everyone was waiting for. Let's just make them cyclic. What's gonna happen in that case? Segmentation fault. Guess why? Because we're trying to reevaluate them aggressively, that's why. So, yeah. Maybe we can even demonstrate that. So, translate. I think I'm gonna do eval expr. Expr eval? Yeah, expr eval. Let's find this function. And let's just print. Every time you do expr eval, we're gonna print expr eval. There we go. So I have to recompile everything, I think. No build. There we go. Shit. There we go. That's actually a lot of expr evals. Oh, I see why. This is because it recompiles the program, but yeah, that's not the point. So let's do bosom. Not that bosom though. Bosom. Yep. So it was actually like constantly evaluating the expressions until it, I think, ran out of the stack. I think it was Stack Overflow, literally. Yeah, there we go, Stack Overflow. So how are we gonna do all of it? How can we prevent the cyclic evaluation? How can we prevent the cyclic evaluation? Well, we need to actually mark the currently evaluating bindings. That's what we need to do. Currently evaluating. So I don't know what would be the best way to do that. So we have evaluated. Maybe another thing would be something like evaluating. Right, so to indicate like the process of currently evaluating. Shouldn't you be able to assign before it's defined? You should be able. So what year is it? What year is it? It's 2021. Stop with these single pass translators and compilers already. 2021. We have very powerful supercomputers that can have like 5 or 10 passes. We can afford that. Seriously, people, stop living in 1970 already. Come on. it's time to move on to 2021, where we have several passes to actually be able to do this kind of thing. Okay? Just look into the future. That's right, comrades. Forward to the bright future. So I need to mark this thing. So evaluating, evaluated. Yeah, I think it's gonna be okay. So eval bosom binding eval. There we go. So we're evaluating the binding, and I just want to remove this entire thing. I'm just thinking what's going to be the best way to do that. So it probably would be better to check this thing here. So you extract the binding, right? You extract the binding and you check. Is it evaluating? Evaluating. If it's evaluating, we need to report the error. What's up, Nulliger? Welcome to the stream. So it's gonna be std error, fl fmt error, cyclic binding definition. Cyclic binding definition. Yes, and I don't think we need anything else, right? So I'm gonna just do a fl arg, and I'm just gonna provide the location. But where is the location though? And why don't you? Oh, I remember why. So because I'm using special mode, and then it's gonna be exit 1. Cyclic binding definition. Also, this should have like a new line in here. Right, and then we're trying to evaluate this entire stuff, and when we are evaluating, where here it is, here it is. So maybe we should actually check that inside, but maybe not. But the idea is the following. So binding evaluating is going to be true. I said evaluating true here. Then I start evaluation here, and then I put false here after I'm done evaluating, and then I assign the value and I say evaluated. Right. I'm pretty sure it will be possible to have like a single variable, maybe enumeration. And then this is the value, and so I'm thinking, where would be better to actually do this kind of thing? So if you're, maybe it should be like this. Maybe it should be like this. If you're trying to do this thing, if it's evaluating, it's a cyclic binding definition. If it's not evaluated, you start evaluating it and marking everything, and I think that's the way to go, chat. FLFMT, so here's the FLFMT, and it compiled. Let me actually run the tests to make sure that everything is okay. And cool, so let's go back to our example. Our example is test bosom, right? So here's the test bosom with cyclic definition. So let's try to do the following thing. It's going to be build bin bosom, and it's going to be example, not really example, but test bosom test bn cyclic binding definition. Cyclic binding definition, but if you don't do that, if you put 10 in here, it will compile. But if you try to cycle them, it will not compile. Furthermore, you can do something like this, const ca, and it still does that, unless you uncycle it. How about that? So we literally detect cycles in the Graph as bindings. and we report that, but we report that in a wrong place though. Columbetka, hello, welcome to the stream. So location is not particularly correct in my opinion, so we have to provide the location of the binding itself, in my opinion. So yeah, location of the binding. I'm pretty sure binding should have its own location. Yeah. Alright, so let's actually run the tests. Cool. The tests pass, and okay, test C. Yeah. And there we go. It actually points at this thing. So essentially, it detected the cycle at around here, right? So it tried to evaluate this again, but it was already evaluating. So that's why it detected, and it actually reported it here. So, but then if we break the detection, yeah, perfect. That's pretty cool. I pulled that off. Holy shit! I pulled that off. Oh fuck. Sometimes, like, I don't realize what I just did. I implemented the binding system with dependencies and it detects cycles. Holy shit! I didn't expect that it's gonna be that easy. Ah! Holy fuck, it's so cool. Okay. Huh. And it totally makes sense, like, the types work out really well. The only thing I'm not particularly happy with is this variable. Like, additional variable doesn't really make that much sense. Hello, Old9. I don't know, I think PHP is better than both Rust and C++. I wonder if I can squash together evaluating and evaluated. So, and introduce something like binding status, right? So, binding status. So, and it's gonna be something like binding evaluated, unevaluated. You know what I mean? So, like, several stages of the evaluation of the binding. And I think it should be possible. Yeah. But the problem is that the names are not really clear. So it's really easy to confuse evaluating and with evaluated. So I think it would be better to have like something else. And of course this one has to be 0. Okay. Binding is a constant variable. Yes, it is a constant variable. Undefined evaluating done. I don't know. I guess we can keep it like that. So then we can have binding status, right? Status, and it's just gonna be status. So, and following the 0 rule, it's gonna be unevaluated initially. Okay, so let's try to do that. Type def enumeration, and let's go. So evaluated, it has to be like status binding evaluated if we want to do something like this. Yeah. So, and if binding status binding evaluating, right, evaluating, so you're gonna actually drop it. If status binding unevaluated, we're switching the status to binding evaluating. and after we're done, we're switching the status to evaluated. Oh my god, that's perfect. So it is possible, right? So you start evaluating the binding, and you check its status. If it's evaluating already, you found the cyclic definition, go away. So if it's unevaluated, we switch the status to evaluating and start the recursion. And after the recursion is done, we mark it as evaluated and set the value. This is perfect. So it's even more readable with enumeration than with two booleans. Okay, so we have a single variable, and it's just different stages of the binding, and it's, oh my god, this is so satisfying. Holy shit. So what's being evaluated for those bindings values? Bindings store expressions. Expression is AST. AST, nodes of the AST can depend on other expressions. So when you evaluate the binding, you start interpreting the AST, which will trigger evaluating other bindings and so on and so forth. But sometimes bindings may depend on each other, and we need to detect this kind of situation. This kind of situation is detected by marking the status of current bindings. So if you're trying to evaluate bindings that is currently evaluating, that means in your recursion, in your DFS, you hit the cycle. And this is a forbidden situation, and you report that and you crash. So this is basically what's going on. So we're evaluating just values, numbers, if that makes sense. Okay, I'm really glad that it makes sense. So essentially, exactly what we're evaluating this. So this defines a binding. So we have three bindings in here, A, B, and C. So I bind A to 69, then I bind B to A, and then I bind C to B. So now I have dependencies for three bindings, right? And so essentially, if I try to recompile all of this, first of all, I need to recompile my entire toolchain. Just to test things, and then I'm gonna try to compile my program. My program compiles perfectly because, as you can see, there's no cycles in these bindings. But what if I cycle them? So A is 69, B is A, C is B. I can try to put like C in here, right? And yeah, it's a cycle found. So as you can see, there is a cycle between their definitions, and it's just not gonna work. And the easiest cycle to understand will be something like this, right? A is equal to B and B is equal to A, and there you go, cyclic definition. This is not allowed. You can do something like this, and this is allowed. But now we have unknown binding, so I'm gonna remove it here, and then go. So yeah, that's exactly what we're doing, and yeah. It's pretty cool. Actual programming language. All right. So I'm gonna remove this program. So what did I do here? So the problem is 177. Yeah. Refactor BASM resolve binding, and here I introduced the expression. Okay. 177 implement binding evaluation. Let's push that right into the ribbon. Okay, so this issue is done. Now bindings can have expressions in their values, and the evaluation of this expression is deferred, and everything is cool. And we're ready to implement a very epic feature. We are ready to implement a very epic feature. Add expression support for bindings. So let's see if all of that builds on all of the supported platforms. This is quite important. This is very, very important. But what are you naming your language and extension, or am I misunderstanding the concept of developing language? Well, let's put it this way. The name of the language is BASM, but the name is not that important. I mean, it's just a name. I mean, it's just a name. I don't know. Is choosing a name for your language is part of the development language? I don't think so. We can argue here, but in my according to my definition, it is not. All right, so it doesn't compile on Windows. Let's see why. Okay. The following warning is treated location hides previous local declaration. Okay, so this is fair enough. No, according to my definition, choosing a name or logo is not part of the language development. All right. So there is a location redefinition, and maybe because of that, I wanna actually, yeah. Where's the other locations? Okay, so. Exactly. You note. All right. So binding, deferred operation. So this is probably why I didn't have a location here. Okay. Okay. Try to fix MSVC build. Fucking classic. Yeah, like every time I make a pull request, I have to make that commit. Fix MSVC build. Fucking classic. But I mean, this time, I mean, it's actually a pretty good point. MSVC did a pretty good point. So I don't know why I'm bashing on Microsoft. No, you can get banned on Reddit if you bash on Microsoft. Did you guys know that? It's dangerous to go alone. Take this. So I really want to merge this pull request because the next feature is going to be fucking amazing. We're going to introduce mathematical expressions. Yeah, that's what I want to do. What's the lore behind getting banned on Reddit for trash and MS? I don't know. It's something that we discussed on Discord today. Mathematical expressions will be hard. So, I mean, how does Python do it then? If it's so hard? Or do you have to be like a genius to, like, is it created by genius? Is Python created by literal genius? That's why he can do that? I remember, like, it reminds me actually of one of the rants of John Blow when he was demoing his language, and he talked about when he announced that he's gonna make a language. He started to receive different emails, and one of the emails was that he's not going to be able to create a language because parsing language is a very hard problem. This is literally what the email says. Imagine telling John Blow that parsing is a difficult problem or something. I don't know. Well, what else can you tell John Blow? Tell him that game development is hard. So imagine like John Blow is streaming, like come to his stream and just add him and say, Joe, did you know that game development is hard? Did you know that? Anyway. Ban any percent, yeah. So did you know that software developers... No, I didn't know that. That's probably why I've been doing that for 15 years already, because nobody told me that it's hard. If I knew that it's hard, I would never fucking get into it. Yes, I didn't know that. All right. So let's merge this shit. I wish somebody told me that software development is hard, like unironically, so I would never actually get into it. So, and just continue being a musician instead. Because before I got a computer, I was planning to become a musician, right? I was planning my career, stuff like that. But then my parents bought me a computer when I was 15, and all of these plans went to shit. So, and I became a programmer instead. I hate when people say that parsing is a solved problem because it is not. Sure. I guess. It depends on the definition of solved, on the criteria of being solved. Sure. According to your criteria, maybe it's not solved, so then it's fair enough. So, JSON parse is solved problem. Anyways, so let's continue. Okay, so we're gonna start adding things incrementally. We're not gonna start doing very complex thing. I just want to add, you know, plus operation, simple plus operation, and the test for this plus operation is gonna be pretty simple. So test boson, right? So it's gonna be const a should be equal to 65. Maybe to 66, then b should be equal to a plus 1, then c should be equal to b plus 1, and then d should be equal to c plus 1. And if we manage to make this work, I think we're gonna call it a success. That's gonna be at least the plan for today. So then we define this kind of thing, and we just push all these things onto the stack. And then we're gonna check all of that in boson itself, right? I'm sorry. So entry main. Okay. So if we try to compile all of this, this seems to be working. One 178. 178. Oh my god. Need more water. So first we're gonna start with the tokenization. So we just need to be able to learn how to tokenize plus. All right. So I think the easiest way to do all of that is going to be by creating a simple program. It's going to include src bm.h, and then we're going to define bm implementation, and just like that. And maybe I'm going to just remove this entire thing, and we're going to have tokens, right? Fucking tokens, mate. So then we're gonna do tokenize, but though src bm.h, yeah, reload, do you think? I don't care. So then we're tokenizing, and the question is, so it also accepts file location, but I don't really have any particular file location. Maybe I'm gonna just define like a fake file location. So in the file location, what do we have? I don't even know what we have there. So I might as well just fill everything with 0. Okay, so we're going to provide the tokens, and the source is going to be SV from sister. SV from sister, and we're going to have a plus 5. A plus 5. So that will probably work incorrectly, alright, but that's kind of the point. Size 0 less tokens count plus plus I. And so let me introduce a function const char token type as sister. So I'm gonna accept token type. So and then we're gonna do switch type. And let me go to bm.h and find token type. Oh, it's called token kind, unfortunately. Yeah, it's called token kind. Sure. Why not? Why not? It's gonna be case, and I'm gonna query. By the way, I forgot that maybe I want to use cpc. Query replace this thing with that, and essentially, I'm gonna just return this thing like that. Cool. Now, so essentially, what I'm going to print here, I'm going to do s token token kind as sister. Token kind as sister, and it's actually not a type, so it's a kind, and this is also a kind. Also a kind, and tokens, I think it's called elements. I don't remember how I call them there. Tokens. They're called the elements. Okay, cool. So, and if I try to compile this entire stuff, hopefully that will compile main.c. And it didn't compile because why? So I have to provide the kind of the token. There we go. So, and if I try to run that after that, let me see, it's gonna tell me that I have token symbol, token symbol, token symbol, and in my opinion I have too many symbols. Oh, this is because I duplicated the line accidentally. Okay, so I have 3 symbols, which is... how are you planning to do precedence parsing? Prat parsing, shading yard, or just on a level of grammar? The dumbest parsing for now. So if you Google precedence climbing, right? Precedence climbing. This one. And in Wikipedia, there is example of a dumbest solution ever. Where is it? Yeah, this one. I don't know how it's called. The dumbest climbing. Oh, on the level of grammar. For now. So, because I don't want to spend too much time on this thing. Once the performances start to get affected, we can come up with something else. Sure. So, yeah. On the level of grammar. Okay, so here's the tokenization. And let me go to the bm.h, and what we need to introduce is a plus. Right, we need to introduce a plus. And then I'm gonna put this thing here. Show CMD thing. Okay, Sojin, what do you think about... Ayguduk, what's up? How are you doing? Welcome. Okay. Nice. So, where's the tokenization? Tokenize... Doing well, but a little bit busy. Yeah, I see. It is what it is, and it isn't what it isn't. Okay, so let's take a look at some stuff. Rust, most loved programming language in last 5 years. Well, I guess that confirms the phrase of Straustrup, right? He said that there are two kinds of languages: the ones that everybody hates and the ones that nobody uses. So yeah, there you go. Loved language, by the way, for 5 years. And let's actually push the token there. So we're gonna push. I actually want to chop a single character. Oh yeah, and chopping the single character actually returns the thing that we can. That's actually fucking perfect. Okay, so it's gonna be tokens. Token. So it's gonna be plus, and the text is gonna be as we chop left, I suppose. Source 1. Cool. Afterwards, do we need to return anything? I don't think we need to return anything. It updates this entire stuff, so should be okay. Yes. Cool. And there we go. We managed to parse this shit. So we have symbol plus symbol, and we can also test that like this. Right, you see? So if I do plus, it's symbol. Nice. I'm super happy. Haha. So I think the time has come to actually maybe introduce a token name, right? Token name, right? If it starts with alphanumeric, with alphabetic thingy, with alphabetic character, we should basically chop the characters until we see something non-alphabetic and treat it as a single token, so it's possible to parse something like this, right? So that's what we should try to do here. I think, maybe, I'm not 100% sure, but yeah. Or maybe we can define what is a part of a symbol, like what characters are part of a symbol. Allow variables starting with numbers just for fun. Sure, feel free to submit a pull request. And we can discuss that, but again, submitting the pull request does not guarantee that I'm going to actually accept it. So it has to be properly implemented. It should pass the continuous integration, right? Should be readable. The code should be good, but I believe in you. You can do that. Alrighty. Should pass MSVC? Yes, it should also pass MSVC. It's quite important criteria. So I think we need to introduce some functions, something like is symbol, right? Is going to accept the character. Let's mark it as a static. So, and we want to define the characters that are symbols, right? So if is alpha, I think it's called alnum, is alnum. Oh my god. No, I'm very sorry. I think I want to make a small break. Just a second. 3 minutes. Right, have fun. Hey yo, what's up? Welcome back. To back. Sorry. So it's a symbol if it's all num, right? And it's gonna be that. Or I guess we can do something like this: return that, or it's equal to underscore. And maybe we can have additional symbols. Right, if it's all num and additional symbols. This one could be complicated. So because we need to be able to parse the number literals somehow, and the number literals, it actually depends what kind of number literals do we have, right? So introducing that may actually trigger pretty interesting chain reaction that I don't really want to trigger right now, because yeah. Okay. So if you're doing chars for now, could make a table with flags, check table, start content, etc. Thank you, I suppose. Thank you so much for the advices. Okay, so if it starts, yeah, if it's something else, right? If it's something else, how are we gonna approach all of that? So we chop by, yeah, we chop by the delimiter, so this is the space. SV index of, I think is, so we want to find, so if source data, cool, the source data, right? So if it's an alphanumeric, so we're gonna actually take while it is alphanumeric, right? So we're gonna do it like this. So it's gonna be start, and just do it while is all num source data, and we know for sure that we have a single character here. This is not how we do that. So first of all, I should be less the source count and plus plus, right? There we go. Then we have this thing. We should be able to construct a new string in there and call it a name, right? Oh, by the way, I think it would be better to call it is name. So basically any symbol that is a name. That is a name. Okay. Boolean. So it's gonna be char x, and it's gonna be is all num, and something like this. Okay. So this is going to be that. Maybe it would be nice to have a function like take while or chop while. Yeah. So something like chop while, if you know what I mean. Because I feel like I'm gonna use it quite often, right? So let's actually do that. So it's gonna be string view. sv chop while, right, and it accepts the string view, the one that you're going to be chopping, and then it's going to accept the predicate. So the predicate is going to be boolean predicate, and it's going to accept the character x. Heard about that C also has generic. God damn it, Out9, you got me. Stop. Where's my phone though? Did I leave it somewhere? Just a second. Okay, this seems okay. I'm okay, thank you, June. Everything's okay. So sometimes it's kind of difficult to focus. All right, so count, right? So while this is that, and then we're gonna do what? It's gonna be data I predicate while predicate, and we're gonna be just increasing this entire thing. So next we'll need to. Yeah, we'll need to construct a result, so it's quite important. We need to construct a result, and the result is going to be what? So count, I is the count, and then we're going to have a data, which is equal to the beginning of the data. Right, there we go. And then I should be returning this data, but I need to update SV as well. So count is going to be plus I, and the, well, it has to be minus 1. Data is going to be plus I. You know what? This is literally chop left, isn't it? So essentially what I have to do here, I just have to do SV chop left, SVI. Yeah, this is basically what it is, isn't it? So in that case, I think maybe something like n would make more sense, but I already called it I, so it doesn't matter. So you can chop left, and maybe you can also chop left while, right? Yeah, so you can just do that, I guess. And it has to be returned. Usable code? Probably, I don't know. I don't know. So if this is this thing, I can now have a name, right? Name, and I can do sv chop left while source, a pointer to the source, of course, is name. There we go. And after that, I can just create a new token, which is token kind name. Token kind name. So we have a symbol, but now we're also going to have a name. So in the case of bindings, we expect specifically names. In case of numbers, what do we expect? Numbers usually start with a number or dash. So this is quite important. They either start with a number or a dash. But then we're going to introduce a problem with distinguishing minus and how is it called? Unary minus? Or maybe not, because we can just parse the unary minus as usual, and then, okay, that makes sense. That actually makes so much sense. So let's also try to parse minus as well. Right, so for the literals, it's just like, yeah, you parse it as a literal, and then if it has a minus in front of it, you just treat it as a negative one. So that makes way more sense than I thought. Okay, all right. So you see, maybe parsing is not as difficult as people say it. Yeah, maybe it's a little bit easier. Just a little bit. Not too much, but just a little bit. Just saying. So plus minus name, and we might as well actually introduce like a number, token kind number, right? Yeah. We'll be able to do in the future, yes, in the future, yes. Valseki, hello everyone who just joined recently, really glad to see you all today. So tokenize. So, and then I can do tokens push. It's gonna be tokens. So it's gonna be like this. Kind token kind name. Thank you, Emacs. Very cool. And the text is gonna be just a name. And I wonder if I can simply inline this entire thing. I think I should be able to just inline it like that. If it's I is alpha, so you can just do it like this. All right. So that's pretty cool. So otherwise, if it's a digit, right? So if is digit source data. So we have to probably do a similar thing, but we're gonna do is not space, right? So just is not space, which is essentially chop by delimiter, right? So chop by delimiter, and the delimiter is going to be literally just a space. So yeah, and then if it's incorrect, what about minus 10 though? It's a good question, but maybe we shouldn't care about it right now. Won't is alnum also grab digits? Yes. In case of x10, I want this to be a variable, I think. Oh yeah, you mean, oh okay, I see. So it has to be alpha, but here we have to use is name, which also includes up. Okay, I see what you mean. Yeah. Thank you so much. Yeah. We can probably introduce this number, maybe. Yeah, for now. So it's probably going to be a very dumb solution, but yeah. So is name, yeah, let's introduce it like that. So it's going to be char x, and return is going to be is digit. By the way, or has to be or dot, right? So or x for hexadecimal stuff. Oh, and hexadecimal can also contain some other things. Okay, so yeah, we basically were depending on the fact that we just, you know, separate by certain names. So yeah, we need the hex numbers, by the way. Just make it do and let someone implement it. Yeah, maybe we can try to do that, but yeah. Well, to be fair, we can try to use something that is alpha num as well. Is al num, or this, or like it also includes that. Do we need anything else? Yeah, I don't think so. Yeah, this is gonna be the number. Yeah. So, and then the actual parsing and checking is going to be done on the level of parser. Right, so I think that's the easiest way to go about that. And so this is going to be a temporary solution, of course. Unknown token starts with and we're gonna provide the token, the thing itself, so source data. Cool. So, oh, yeah, now we'll have to go through all of the places where we used to use those numbers. So is number, okay, so I forgot a semicolon? No, I didn't forget a semicolon. It's not a trouble delimiter, a left while. Oh, simp-cmod, there we go. Alright, so this one is interesting now. So we do the actual parsing, and in a symbol, right, in a symbol, we're trying to first parse it as numbers, and if it doesn't work, we're trying to parse it as the value. Shouldn't it be also token kind number? Probably. Just a second. Token as a, did I forget to update the? Yeah. Thank you so much. I'm already falling asleep. Okay, let's make a cup of tea. So this is a temporary solution comment above written 10 years ago. So this is somehow inherently bad, right? Right. So the fact that you came up with a solution that worked for 10 years, think about it. Solution that worked for 10 years is inherently bad. Is that what you mean? So, or are you like upset that people 10 years ago couldn't predict the future? That something better wouldn't be needed? Is like, so what? Like, I mean, we have to celebrate that we came up with a solution that worked for 10 years. This is fucking amazing, isn't it? Huh? I remember seeing you in some Linux related talks. Okay, I'm gonna go turn on the kettle and make a cup of tea because I'm already falling asleep. So let's take a look. So now we don't have a symbol, but we do have a name, right? So we do have a name, and if you're referring to some sort of a name, you're essentially creating a binding, right? So in that case, we want to just set binding like this. So result has to be binding and the kind has to be binding, and we just return the result. just return the result. And maybe at this point, yeah, we should just return this thing here and don't worry about it. Yeah, so I thought it's not going to be the case, but apparently it is the case, so whatever. So we just set all of this thing here and then chop the tokens. Hopefully that is not gonna break too much. Okay, so here's the name, and then case token kind. It was a number, right? It was a number. And in case of a number, so we're doing this complicated thingy. So I might as well actually do a number here. Just do a number here. So we try all of these things, and at some point we hit this situation. That means we couldn't parse it as anything. So we need to indicate that this is not the correct number. Not a hex literal, and we can do a similar thing here. Not a number literal. And let's see how it goes. So let's try to compile this thing, and it doesn't properly compile because this is not the text. But where can I get the text? I think this is where can I get the text. So here it is. My tea is ready, by the way, but I want to finish the thought before I go. So this one is going to be name, and it worked. So you have a name and plus, but you don't have a number. Yeah. Epic, and it's also segfaulted, by the way. Very cool. So the question is, why did it segfault? Why did it segfault? I wonder. What do you guys think? Because it probably tried to touch unmapped pages. Don't touch unmapped pages. Because it's C. I don't think it's because it's C. For example, Java is written in C and it rarely segfaults. Yeah. So let's actually see where exactly it crashes, right? So if I try to run main in here, it segfaults. And I think I need to rebuild this entire stuff with GDB stuff. Alright, so I think I'm in the wrong place. So I have to go somewhere here. Okay, GDB. And let's just run it. And where did it fail? It failed at puts. Really? Is that where it failed? Huh. Excuse me? I'm quite confused. So it failed at printing things, and I'm doing a very simple thing. I'm just mapping a kind. Alright, let me try to just map like D in here. That doesn't particularly make any sense. Like, why would you do that? N, oh yeah, so I'm not sure. 5, 2, 4, and okay, so token kind name. Yeah, string char plus number, and oh, I think this is because I didn't parse all of them. That's probably what I have to do here. And yeah, it's a classical situation. It's a very classical situation. What can I say? And we just return this thingy. Alright, then just return this thingy. And maybe I'm gonna do token kind as a C star. Yesu, kawaii desu. And this one has to be just S. And name plus number. Would you look at that? It's a name plus number, right? And it's gonna stay the name plus number no matter how many spaces I put in here. This is absolutely amazing. I can just do A plus B as well, and it just works. A plus name. So it could be also 5 plus 5, and it's a number plus number. Isn't that amazing? I think it's goddamn fucking amazing, mate. Oh my god. Oh my god. Mein Gott. Cool. Tokenization. Happy tokenization. Cool. So I wonder if I broke anything, so I probably need to rerun my tests. Ah, it's too heavy. My tea is too heavy. Oh boy, oh boy, oh boy. Cheers, everyone. Ooh, it's a little bit hot. It's a little bit hot. Yeah, that's hot. That's hot. Welcome back, 2018. Best year of all time. That's hot. I think it was already like 2 or 3 years ago. Yeah. So that meme. It's already a boomer meme, I suppose. Okay, I wanna rerun the tests. I wanna. That's funny. Nice. So you guys figured it out. All right. So it's gonna build. This is not what I wanted. I wanted to do no build. Oh shit. So it's inside of BM. So maybe I'm gonna actually mark it as static. Okay, so chop left and SV chop. Yeah, there we go. We have more and more functions to do. So essentially rewriting aids in C. So we also have not full. So this is a number, this is a name. Token plus. Oh shit, okay, so when we're parsing things now, yeah, okay, that makes sense. So I'm gonna put case token kind plus, and it's gonna be just like this. And another one, what is this? I thought I already taken into account plus. What are you talking about? Oh, and also minus. Okay, sure. If you want minus. Oh, and this is where we'll have to handle all this stuff. So yeah, the parsing may unknown token starts with, yeah, there we go. There we go. So now we need to do this kind of stuff. So now we need to tokenize, like extract token minus, and then in the parser, when we encounter minus, we need to expect the next token to be number, right? We need to expect the next token to be number, and then we should parse the number and basically negate that number, right? So that's what we need to do here. So yeah, essentially that's what we're gonna do here. I'm a little bit tired. Maybe I want to make a small break. Maybe not. I need some music. I'm just like a little bit afraid that I'm gonna go into too deep of a rabbit hole and forget what I was doing. So, which happens quite often, but yeah. So And once I forget what I was doing, I'm gonna get extremely discouraged to do anything. So it's quite important for me to not get into such rabbit holes. So kind token chop left is going to be source 1. Okay. And it's probably going to break. Okay, so yeah, that's exactly what happened, because you got a minus and yeah, cool. So maybe we should introduce like parse number specifically, so we can parse an expression from tokens, and you need to be able to parse a number from tokens. Right, parse a number from tokens. And depending on that number, we're gonna negate that. Okay. All right. So parse number from tokens. So it's gonna accept the arena. I'm not sure where arena is needed here, but yeah. So then tokens and then file location. We do need a file location to report the errors and whatnot. So I'm gonna move all of the number parsing there. All right, I'm gonna move it there. And specifically what we expect here, we expect the first token to be number, and if it's not a number, we can say that explicitly. So let's quickly do that. If, well, yeah, I have to also add this condition here, and then if tokens elements kind not equal token kind number, if it's not equal to number, well, it has to be equal to number, and then we're going to try to parse it as a number. Right, we're trying to parse it as a number. So in that case, I can just literally move everything there here. Right. So otherwise, we need to report an error, because saying that expected number but got something else. So I also can define an expression result in here, right? So which is going to be returned at the end of that function. Yeah, so I just need to return the results. Chat, why are you dead? So am I being that boring? I'm really apologize that I cannot explain everything I'm doing, because it's kind of like a, it's parsing. It's kind of parsing. So. So by the way, ordered myself GK61. I don't know what it is. I have no idea what it is. Thank you for sharing. Hello, Carrington. Background music. Thank you for coming here for background music. Just looking while writing my boring PHP code. Really? I thought you're a Python developer. You're not Python developer anymore? Oh, you're getting ready for the interview. Good luck on your interview, by the way. Can't really focus on your stream. Oh, okay. That's okay. So, I see. I understand. I'm trying to copy your Emacs theme on VS Code. Why? So, I think Out9 was already trying to do that. Out9, are you still here? I remember you were trying to port Gruber Darker to VS Code. I think you still have it somewhere. I'm working around. Alright. So you're feeling right now. GK61 is a mechanical keyboard. Okay, cool. I didn't know that. Yeah, I'm feeling right now as well, I suppose. You can literally feel me, see me. Well. Oh yeah, thank you for sharing the link. Yeah, this one. So you see, you don't have to do that. Oh, no, I already did. Sodding feeling. It's like sodding pogging, right? So, but sodding feeling. This one is not a number literal. So let's actually print an error. Stream is Pogman. Pogman? Any Pogman? Alright, std error. FL FMT Pogman. There is an emote, Pacman, I think. Pacman. I don't think it's that one. It's one variation. Maybe Pogman. Pogman emote. It's not that one. I cannot find it. I'm sorry. I'm using Google to find it. I'm trying really hard. Somebody's. Okay. Alright, so FMT error expected as but got as. So, and this is where we can do the following thing. Token kind. Oh yeah, thank you so much. Yes. Thank you. Yeah, that one. Oh, I wish I could edit. We don't have slots, I think. Or I also need to log in. Oh, it's too hard. Oh my god. Thank you so much, Odnan. By a lot of emotes and look at PTTV. You see. Yeah. I wish I could edit, but it's hard right now. So it's such a cool mode. Token kind as sister. Token kind as sister. So we expected token kind number, right? So this is what we expected, but got token kind as sister. So it's going to be actually the actual token kind that we got, which is not the one that we expected, unfortunately. And it would be better maybe to call them slightly differently. Because we don't want like to print their internal names, so maybe we want to actually name it a token kind name, so it would say like words like number or name or something, right? So expected that but got something weird. So I think it's a little bit better this way. So then we're gonna do exit one. All right, so this is the function that parses a single number. Alrighty, so if I try to compile this entire stuff, I wonder what's gonna happen. So it does not particularly compile because this thing has to be static. And we need to introduce this function, token kind, and let's introduce it super quick. So it's gonna be const char, and it's gonna accept token kind. Where are we gonna put it? Maybe tokens push. Where is the tokens push function? So here it is. I'm gonna put it here. Right, so I'm going to do a switch. So let me take a look at the definition of token kind and just grab this entire stuff in here. Kind name, here it is. I discarded him today, but this cool indeed. You guys talking about the thing? This dude, is he cool? Let's find out how cool he is. Is he cool as a cucumber, though? That's the question. Kazakhstan. I can respect that. I never been to Kazakhstan, but I know a couple of people from there, and all of them are very cool people. So yeah. Yeah, what's funny is that there is a lot of cool programmers from Kazakhstan. So yeah. It's a cucumber country. It's an ex-USSR republic. So, but after Soviet dissolution, it's a separate country. Okay. And we actually, by the way, I think we're like Novosibirsk is relatively close to the border with Kazakhstan. So yeah, never sure. Why does he mix camel and snake case? Are you talking about me? Because I do that from time to time as well. Oh, okay. Oh, you mean mix in the same... Okay, I see. So because I like to do this kind of stuff, like Ada, Pascal case or whatever. But this is probably not what you mean, right? So, and this is what we can do here. So, string, character, plus, minus, number, name. So essentially I want this kind of stuff, right? I want to convert token kind to these words that I can then use in error messages. So then we're gonna have a default. And then I'm gonna do... it tries to automatically... Yeah, my mode is not particularly great. This kind of thing. So it's gonna be assert false. Token kind name unreachable. Alright, and we're gonna do exit 1. Is it gonna compile now? It still does not compile because I didn't provide the kind in here. Alright, so... Excuse me? Field precision expected... Huh? Okay, so it's probably something weird has happened. Yeah, I see. So I have to use like fl arg, arg location. Right, I have to do it like that then. So arena unused variable, that's understandable. So maybe I'm gonna just mark it as... yeah, maybe I should not accept it at all since we're not using it there. Since we're not using them. Okay, so what else do we have here? So they have that defined... excuse me. Expression from tokens, so... I'm supposed to be pushing arena there when I'm parsing the number. So that's what I'm supposed to be doing. So that means I'm gonna actually return this thing like this. So I'm gonna provide the arena, I'm gonna provide the tokens, and then I'm gonna provide the file location, and that's gonna be it. What else do we have here? This is just a pointer to the arena. Okay, it finally compiles. Alright, so, and there we go. So now, that's the most interesting part. Break. So if you encounter a minus, right, if you encounter a minus, we should expect the next value, the next thing to be a number. So this is essentially what we're gonna do. Chop left tokens, tokens 1, and then we're gonna try to extract the number. We're gonna try to extract the number, and we're gonna save it somewhere here. So this is the expression that we extracted. Right, and then depending on what kind of number it is, right, depending on what kind of number it is, we're going to negate that, right? But it depends on what kind of numbers we have. So expression kind, we have integers and floats. I guess for now that should be enough. So we're gonna switch on x per kind. So if your kind is one of those, right, so we'll have to do it like that. So yeah, so expression value as lit integer, and is going to be equal to that minus that. Then we're going to break. And in case of a float, instead of integers, we're going to use a float in here. Otherwise, in any other case, Oh boy, oh boy, oh boy. Okay, so switches get stitches. This is not a great way to do that, so we'll have to use if-elses. We have to use if-elses. So, yeah. By the way, chat, what do you think? If-else or switch? Which one is better? Which one do you personally use? Switch. Match. There is no match in C, so I'm sorry. Switch. I see. That makes sense. Well, it depends. Yeah, finally, somebody says it depends. Renting time. Yeah. Bike shedding time. Everyone loves bike shedding. Bike shedding. Switch in C is only for compile known conditions? No. So, not necessarily. It depends what you mean by compile known conditions. You can actually mean something else. Assert. And oh yeah, and in this particular case we can, well, yeah. So what we're asserting here is that false, unreachable. Okay. Cool. And in case of a plus, we don't even use plus in here, so that should be okay. Is it gonna compile now? Okay, so unknown binding. Cool. What the fuck was that? Ah, it didn't work. Unknown binding. That okay. Oh, well, wait. So tokens is already a pointer, and when I chop a single character from there, whoa! Please no. Okay, let's try to do something about that. So if I put something like -0,0, will that work? Well, I'm doing the wrong thing, of course. I'm doing the wrong thing, so I need to do main ggdb main c and then main. There we go. So it's minus a number. I also want to print that number. I think that would make sense. So I'm gonna put it like this: svfmt, and it's gonna be svarg. Svarg, and the element here is literally, I think, text, so that should do the trick. And it worked, so, and this entire thing should be parsed as a number, so I don't know why it is not parsed as a number. So, because it's properly tokenized, look at that, it is properly tokenized. So here's your minus, and here's your number. We can even put additional shed in here, right, like A. And there you go, so we have a minus number and A, and if you connect them together, it will still think it's a number, but then it will fail on the parsing phase, so it doesn't really count that much. So then we can do something like this, so we have minus number plus name. Really strange, but yeah. So maybe I should try to parse this entire thing. So I do have parse expression by SV. So, and maybe that will give me something. I wish there was an easy way to dump expressions, and SV from sister incompatible type. Oh, it expects arena. I don't have arena, so let's actually allocate arena. So we're gonna put the arena here, and yeah. So what's cool about new arena, by the way, you can allocate it on the stack because it uses dynamic memory anyway as it expands. Too few arguments. Okay, so what is another argument that I have to provide? Do I have to provide something like this? I forgot what I have to provide. Parse. Oh, I have to provide the location. Okay, so let's provide the location. I do have a location here. Alright, it managed to parse something. So, you know what? I'm gonna save this entire thing to here, and I wanna actually look at that in the GDB. I think in the GDB it's gonna be a little bit better. So I'm gonna break on main, then run this entire thing to enable, and let's print the expression. And what do we have? We have a binding. Oh shit. So this entire thing was treated as a binding, which doesn't make any sense. Okay. So we're not parsing things correctly, right? So parse expression from tokens, and it doesn't make any sense to me. So we take a look at the kind. If we encounter minus, we chop that minus off. That's literally what we do. We just chop it off. And then we try to parse the rest of the tokens as number. And it doesn't work. It thinks it's a binding of some sort. Where did I make a mistake? Alright, so that means I'll have to actually break in here. So that's already pretty good. Alright, I have to break in here and then run it, and let's take a look. Okay, so let's take a look at tokens elements kind. It is minus, so that means we go to the minus, right? We can take a look at the tokens. Maybe we want to dereference them or something. So we also have elements, and I wonder if this debugger can use information about enumerations. Oh yeah, it does use information about enumerations. Perfect. So if I print tokens, so yeah, and I chop left, and I print them yet again. It has a single one. Then I take a look at the elements, and the first element is a number. Okay, so then if I try to parse it, I take a look at the expression. Expression is a float, right? It is in fact a float. All right. I see. I see. Okay, sure. Fucking damn it. Debugger is actually really helpful because it forces you to go through each individual step. Yes. It forces you to do all that. Classic. Classic. Am I right? It's a goddamn classic. Old-time classic. All right. So how about the test? Now let's run the tests. Let's run the tests, and the test has passed. Holy shit! The test has passed. Have passed. Oh, so what did we do here? We introduced like the new things in here and stuff like that. Yeah, that's pretty cool. Expand the set of available tokens. Cool. Expand the set of available tokens. Now, it's gonna be interesting. So, because we need to start parsing the plus things. We need to start parsing the plus things. Okay, let me see. I'm gonna go to the example, and I'm gonna introduce a very simple example actually. Something like 1 plus 2, right? So 1 plus 2, and that should parse into the expression. Well, I mean, yeah, we need to be able to first accommodate this kind of expression, like 1 plus 2. Because right now we don't even have a node in AST for that. So let's find the expression. We have expression kind. So what I'm thinking is that maybe we need to introduce expression kind binary op, right? So we have a binary operation now. So this is the expression expression kind, and also after that we need to introduce a structure called binary op, And what is it going to store? That's a very good question. I think it should store left and right side of the expression. But how is it going to store it? How is it going to store it? So it may actually store them as values. It may store them as values. But in that case, I won't be able to do this kind of thing. Or maybe I will be able. So that means I'll have to define it somewhere here. So here is the binary OP. And then we're going to have a left side and we're going to have a right side. Right, and then we need to be able to convert this thing as binary operation. So it's going to be binary OP, but it's going to be a pointer as binary OP. Alright, and to do this kind of stuff, actually we want to do it like this. It's going to be just a struct, and then we're going to have a type def for this entire stuff. Type def struct binary OP, there we go. That's gonna be the trick. And inside of the binary operation, maybe we're gonna have a binary OP kind. Right, so it's gonna be type def in num binary OP kind, and it's gonna be binary OP plus for now. So we're only gonna have this kind of operation for now, and later we're gonna expand this kind of stuff. Binary OP kind, and here's the kind, and there we go. So yesu. So binary OP kind. Right, and now we need to somehow parse all of that thing. Let me see, is it gonna compile? Yeah, so when we are doing this kind of thing, AST is growing. Yes, AST is growing. PHP 8 plus woo? Who? What? Okay. Now, what we're gonna do? I think we need to take a look at this thing. President's climb. Okay, I already have it here. So usually we define this as a primary, right? This is a primary. And then the main expression is going to be going down like this. Yes, okay. Parse expression from tokens. Parse expression from tokens. And this has to be like a primary expression, right? So expression parse primary from tokens. So it's going to take the arena, then it's going to take the tokens view, and yeah, I want to move everything there because it's kind of related to just parsing. Look at just a regular primary expression. Nothing special. That was a bad idea, I think, but it kind of worked. Wait, no, it didn't. From tokens. So I'm gonna put this thing here. And it's gonna go like that. Oof. Alright, how are you doing, guys? So, I'm a little bit tired, but I really want to finish that. Once we get this thing going, it's gonna be so fucking awesome. It's gonna be extremely fucking awesome, because then we'll be able to do all sorts of cool computations. And we'll also, yeah, we'll probably have to have some sort of like type checking there and there. Right. Yeah. Just taking a break. A little bit tired, but I'm always tired. I'm kind of get used to that. Okay, expression evaluation. Oh, okay. So now we're trying to evaluate the shit. So that's fair. That's really fair. Okay, that's pretty cool. Kind binary op, and let's actually do that. So maybe I'm gonna introduce a function that evaluates a binary operation. So it's gonna be word bosom binary op eval, and what it's going to do is it's going to take the binary operation and just evaluate it, right? I think it's gonna be cool. So it's not a binding, it's binary op. Binary op. So, and I'm not sure if it, yeah, it has to be a pointer. So we're going to be doing a switch. Well, right now there's only one. Yeah, we'll have to do a switch because then we want this thing to actually fail when we add more kinds of binary operations. That's kind of important. That's very, very important. Binary OP. Plus, right, binary OP plus. So in this particular case, right, so we want to take a look at the left part and the right part and just evaluate them at some point, and it will pretty much depend on how we interpret them. Okay, I see now. So yeah, so we're gonna have a word left. Right, word left, and it's going to be bosom expression eval, bosom binary op left, and that will also provide the location because it's needed for reporting errors. Then we're going to have a right. Here's the right, and for now, right, you can reinterpret word in different ways. You can reinterpret it as integer or as a float. But right now, I think we're gonna think of plus as purely integer thing. So that means we'll have to return left as U64 plus right as U64. And we're already writing a compile time interpreter. This is a compile time interpreter, right? It takes the binary operation, it then recursively calls evaluation, takes the left and right values and just sums them up together and then returns it. And then this word can be baked into the operand of one of the instructions. So this is literally compile time interpreter right here. So yeah, we're already going there. But we still have to make a couple of adjustments to make it completely work and compile. So assert is going to be false. Bosom binary op eval unreachable. There we go. And we're going to do exit 1. Cool. So let me see if it's going to do a thing. So yeah, binary op, and we just return bosom binary op eval arena, and I just do expression value as binary op location. Cool. So that should be it. That should be it, chat. And what do we have here? So, oh yeah, so that means next thing I need to do word U64 because I need to like wrap it back into Word. Because Word is a union, so I extract U64 and I need to wrap it back into U64. So another interesting thing, plus compile time. Compile time sum can only do integer. Can only work with integers, right? It doesn't work with floats, and this is because we don't have associated types with the values, with the expressions, right? Because we don't even know which sum to use, and yeah. So we'll see how it goes. So arena and declared. So you don't have an arena here. That's really strange. Yeah, I'm an idiot, so we don't have an arena here. Wait. So the only thing I have to provide the bosom. My bosom already has an arena, so it doesn't matter. Parse primary from tokens. Ariane. It's not Ariane, it's Arena. What next? Alright, so parse expression from tokens. So first thing it should do, it should try to parse it as a sum expression, right? It should parse it as a sum expression. Parse expression, parse sum from tokens. So it's going to be arena, tokens, and location, and it should return the expression, right? And sum by itself. We'll go down into the primary. So that makes sense. Recipe equals code. Cooking according to recipe equals code. Yes. So in this particular case, this should be unreachable. This definitely should be unreachable, 100%. But I'm not sure how to report things here. So, so I'm gonna put it like that: fprintf std error. Maybe I'm gonna do assert. Parse. Maybe it's not a parse; it's parse primary from tokens. Primary from tokens. To do better. Error report on token kind plus in parse primary from tokens. So that's basically what we want to have here. That's basically what we want to have here, and yeah. So then we need to define this thing. Parse sum from tokens. Alright, parse sum from tokens. And how we do that? Well, parse primary. And primary is essentially an expression or a number or something else. If it starts with that, if it starts with this thing, which is fair enough, I think. Oh. So if it's a number, we can treat it as a number. It's a variable, we can treat it as a variable. And plus, yeah, it's gonna actually repeat itself several times. Alright. Okay. So it's a little bit hard, but we can pull that off. Sum. Sum. So first we need to parse the left part, right? So we need to parse the left part. After that, so how do we parse it even? We just call parse primary from tokens. So it's going to be tokens and then provide location. So there we go, we have left. Alright, and while maybe we can actually do that recursively. If tokens count, right, tokens count not equal 0, we're gonna try to go a little bit deeper. Otherwise, we're gonna just return the left, right? So this is how it's gonna go. All right, if it's not equal 0, what we expect here, in fact, is is plus, right? So if tokens LMs kind not equal, how to make chat alive but not distract streamer? You already distracted streamer. Okay. Well, yeah, that's pretty much the dilemma here. You cannot do that. But again, why streamer started to stream if he doesn't want to be distracted? That's a good question. I ask this question myself every day. Why am I streaming if I don't want to be distracted? Alright, so yeah, already failed. No, that was kind of the point, I think. That was kind of the point. STD error. So, and the thing is, we don't know where to report that, but maybe it doesn't matter. FL FMT error expected this, but found this. So, and we're gonna do FL arg location. So to revive the chat, we need to actually, you know, ask something controversial. So something about Rust, maybe. I don't know. Rust sounds like a very old meme. So it's kind of on its decline in terms of memory. I don't know. At least it feels like it to me. I wonder how the general public will receive Jai when it's finally released to like public beta. And I wonder what kind of articles Redditors will write about Jai, right? So that will be actually very interesting. Yeah, Jai is interesting, but it's more interesting how general public will receive the public beta. Just because the thing is, you can get a general feeling that everyone is super excited about Jai, but this is because it's not public and we're basically discussing Jai within our own like bubble, within our own echo chamber, right? So when it becomes like, when it will go outside of that bubble, it might be received like in a very like unpredictable ways actually. So yeah. John Blow doesn't work on his language in a true open source way. Well, I mean, oh yeah, you're saying what's gonna be the topics. Well, I mean, he hates open source. Isn't that the point? It actually doesn't contradict to anything. Yeah, he doesn't like open source, so it's kind of like, you know, expected from him. I fully expect that hardcore OOP fanatics will go read about it, and also probably hardcore functional programming fanatics, because it also has functional aspects, right? It has a lot of functional aspects, but not like, it doesn't pander towards like Haskellers or anything like that, and it can also piss them off as well. Another benevolent dictator for life, so yeah. People will ask to write software on Jai. I don't think so. Actually, I don't think so. I think the target audience of Jai is slightly different from the target audience of Rust. I don't think they will try to rewrite everything in Jai. Like, he hates people who feel entitled just because something is open. Yeah. Yeah, anyway. So I think it will be fun. Not fun from John, for John, but I don't know, it will be fun to read all that. I guess he fully expects that people will react in very unpredictable ways. Anyway, so so what do we have here? It's gonna be token kind name. I developed a lot of GPL code when I was young, but then I realized that GPL is just a cage and not open at all. It depends on the definition of open, but the interesting feature of GPL is that it makes the project unforkable, right? So essentially, if you have a project, right, and somebody makes a fork and it becomes, and the fork becomes successful because of a particular feature, GPL forces the developers of that fork to release it under GPL, so the original creators can take that feature and merge them back into the original project. So, yeah, GPL projects are literally unforkable because every time you try to do that and become successful, the original project just steals it back, and the license is basically for that, as far as I know. Which might not be the case for with MIT, for example. You can do something like you can fork MIT project and one specific feature release it under different license, and MIT will actually allow you to do that. So yeah. But again, I'm not a lawyer, so I don't know what I'm talking about. All right. So, and what we have here? So we expected token plus MIT. My default license is MIT usually. Yeah, MIT. So let me see. By the way, what is the license of your choice, chat? Which one do you use? What is your go-to license? Public domain. Cool. Driver's license. Haha, very fun. Haha. Alright. So then afterwards, TV chop left is gonna be tokens 1. GNU, GPL, WTFPL is very good though. Yeah, I see. WTFPL. Interestingly enough, like every time we're talking about licenses, somebody always brings up WTFPL. But I don't really see it that often in the wild, at least among the popular projects. Not that many popular projects use WTFPL. Maybe because it's obscene? Who knows? Yeah, I guess it's a meme. Yeah, so that's yeah. People bring it up because it's a meme, right? Because haha, it has a swear word in it. Chat, look. It has a word fuck in it. Oh, whoa. Oh my, come on. But maybe it's true. Sure. Maybe I agree with you even. So, yeah. Chop left. And once we chopped it off, I want to do the same thing, but I want to extract the right part. Right, we're extracting the right part. But the right part has to be extracted. Does it have to be extracted like a primary, or does it have to be an expression? I have a feeling that it has to be an expression. Let's give it a try. I think let's just call it expression. So because then it will force it to do like this thing recursively. So this one has to be right. Alright, so now the time has come to return an actual expression here. So this is going to be the result. Right, and the result, if I remember correctly, it has to be something like kind, expression kind binary OP, and then within the binary OP it has to be a pointer. And this is how we're gonna go about it. So I'm gonna allocate a binary OP in an arena. Some crowd country. Alright. So arena alloc arena size of binary OP. Right, and in binary OP, as far as I know, we have a kind, so the kind there is going to binary OP plus, yeah, binary OP plus, then binary OP left is going to be left, and then right is going to be right, and then we assign this thing like that. Looks cool. And after that, we want to just return this entire thing. Sure. Oof. Yes. Okay. That looks cool. Cool. Is it compile? It does not compile. No previous declaration. Okay. Parse. So let's put it here. So now we have a declaration here. So what's next? Ariane. Who's Ariane? Okay, so unknown type binding OP, binary OP. Binary OP, binary OP. Alrighty. I think it has to be a value. Yes. Okay. As binary OP. Oh shit, it's compiling. Oh shit, it's going. Fuck. Okay. Expected plus but found name. Alright, so expected shit, fuck. Damn. Okay, good. So expected plus but found name. Yeah, I guess. That's what you found. What else did you expect, bruv? So expression, we're parsing tokens, right? We're parsing tokens. And after we parsed them. Wait a second. Like, how did it even parse it? So, do we have underscore in our names? We do have underscore in our names, so it should be supported. So, okay, let me try to parse or at least tokenize this entire thing. So we're gonna have sv from str. So this is gonna be the thing, and I'm gonna try to tokenize using arena and fake location, and then yeah, I'm gonna iterate through all of this shite. Oh shit, we lost so many people. Yeah, because I'm being boring and not interesting. I'm being very boring, chat. I'm not acting like a clown, right, all the time. But instead, I'm actually trying to write a code, right? And that is very, very bad on Twitch. You're not supposed to be productive on Twitch. You're supposed to interact with people and be funny. And I'm not doing that, and that's why people leave in. Oh my god, what do I do now? I don't know, chat. I don't know. What do I do? Should I say something controversial? Should I say something controversial like Rust is better than JavaScript or something? I don't know. What is controversial these days? Tokens, token kind. You need add memes to code. So should I rename tokens to memes? Maybe that's gonna be the will attract zoomers. Oh shit, I'm sorry. I really apologize for saying that word. I'm really sorry. So I'm not the ageist, okay? So I don't, you know, shame people for their age, something they don't control. Okay, I'm not using that word. I really apologize. Please Twitch, don't ban me. Okay, so what I wanted to say is tokens elements I and is going to be kind, right? And then so another thing is going to be the actual text that we're trying to print there. What's up, Anabothel? Hello, how are you doing? Oh shit, I'm doing the wrong thing actually. So I need to build this entire shit. main.c, maybe even ggdb, and then I'm gonna try to run this shit. We're almost done on a both. Oh shit, incompatible type with the argument. What do you expect? Oh, it just expects the source code, sure. Do you need location? What do you want from me actually? Oh, I think it expects a pointer to tokens. Yeah, that's what it expects here. Source tokens location. Okay, I see. Source token locations. But Zozin, why you're not controversial? You're not controversial. Okay, so everything was okay. Jiang, you got me. I really apologize, Jiang. I'm gonna try to stop. All right. Beautiful. So, why this shit doesn't work? That's a good question. Like, if I try to parse it as just a thing, like it should just work then, right? So we parse the token, we try to parse it as a sum, right? So we parse it as a primary thing, right? We parse it as a primary thing. And when we parse sum as a primary, so this is the, yeah, it's just a primary and primary, nothing special. So this is a primary. Maybe that's exactly why I have to do it like that. I see. It has to be primary like this. Yeah, that makes sense. Sure, that makes sense. Okay, so let's go and just rebuild everything like this. Hopefully, maybe that will make it work. Why doesn't this work? My question is now, why am I so dumb? Yeah. It just doesn't... Okay, so that means this should be reproducible here. Right, so I'm gonna try to parse expression from SV. Do I have to provide arena? I think I have to provide the arena, just in case. And I also have to provide the location. This is not what I wanted. I'm sorry, Zhang. Alright, so yeah, that happens as well. So let me think. So we have a single thing that is a binding, right? So essentially what will happen, we'll try to parse this entire thing. So then we try to parse that, and then we're gonna hit the primary. And inside of the primary, we're gonna find the name. Oh yeah, that makes perfect sense. I forgot to chop off the binding out of that thing. Out of damn thing. Okay. Alright. So then we have a minus. And yeah, so that makes perfect sense. Thank you. Very cool. And that works now. So now if I try to do a building... Oh shit, it compiled. But is it gonna pass the tests? Please tell me that it's gonna pass the tests. That would be fucking amazing, mate. Oh shit, it passed the tests. Oh my god, chat, are you ready? Are you fucking ready, mate? So we're gonna do the test boson, right? So here is our test case. Here's our test case. We defined A, which is 66. Then we defined B as A plus 1, then C as B plus 1, and D as C plus 1. And we just push them in a row. So the idea is that all these things should be computed at compile time, and they should be baked into the operands of the push operation. So let's see how it's gonna go. I'm gonna try to go ahead and actually run this thing on this test example. So BME, yeah, not really BME, but boson, and the input is going to be test test boson, and output is going to be test BM. All right, so that created the thing, and now I can try to deboson the BM file, and if we see the values, I'm gonna call it look at that. Look at fucking that. This is so beautiful. I'm gonna show you the original source code. The original source code looked like this. you have A, 66, A plus 1, B plus 1, C plus 1, and then you push them here, and here you go, 66, 67, 68, 69, and hold. All of that got computed at compile time and got baked into the instructions and shit. Furthermore, we can maybe try to do something like, you probably should be able to do things like, I don't know, like 400 plus 20, right? 400 plus 20, and that should work as well, probably. I'm gonna recompile everything, right? And then I'm gonna rerun debusm, and it worked. Look at that. So I can have these expressions like in line as well. Yeah, so that's pretty cool. But you won't be able to do something like that, I think. If you try to do something like that, it's not gonna compile at all. Because you're basically created a cycle, right? So you created a cycle, and it will tell you cycling binding definition, and it just shows you listing here. Cyclic binding definition. Yeah, it also detects the cycles. That's so fucking awesome. Wait a second, I cannot believe that it just works. What about like push 1, 2, 3? This should also compile into 6. Can you do? I should be able to. Okay, so yeah, let's actually test all of this. Okay, so compiled 466, and also it supported like chained expressions here. So 3. There we go. We don't have too many operations yet. Right, and we don't have like multiplication, division. We're gonna add all of that later. Oh shit, it's supposed to be 6. Yeah, you're right. Oh fuck. I see what's happened. I see what happened. That's exactly why originally I was trying to do the following thing, where the right part should be parsed as expression. Yeah. Okay, let me quickly fix that. Russian arithmetic. I mean, I'm tired. Just give me a slack, okay? Okay. There we go. 6. Fixed. Fixed. You know what? I'm gonna actually add all of that to the examples. Right, I'm gonna add all of that to examples. It's gonna be test. And it's gonna be compile time. Compile time express. Yeah, compile time express. And the thing is, here's what I'm gonna do. Right, so I just edit a new example, and I'm gonna run a simple command, no build record. It will recompile everything, and it will regenerate all of the expected values of the examples. So now you have compile time expected, and it doesn't have anything. Yay! Because it doesn't print anything on the standard output. So yeah, what you have to do, you have to go here and actually print all of them. So the way we're going to print them actually is we're going to include examples natives hasm, right? And for each of these things, we're going to do call dump u64. I think that should be enough, right? Dump u64. So basically, we're gonna print each individual value and see how it goes. Yep. And let me try to rerun record one more time. So in that case, it will actually print the things. Okay, expected, and let's revert this value. And there we go. So here are the expected values. And now, if I rerun the tests, it will use those expected values for testing. So, and for example, if now I will bring back that error that I introduced accidentally. So the error was actually very simple. I just used prime primary instead of expression, and I will try to recompile everything and rerun everything. So the test should complain. And the test complete. So you see it says expected value is line 6, but actual is 3. So that's how easy it is. So we have like a tool that lets us say, okay, the current behavior is the correct one. And it basically records the outputs of all of the programs. And then later we can say check it against the expected value, and it checks it like that. So we don't have to like maintain too much. The only thing that is required is just drop a file into the examples and just say record, and it will create new test cases. It is very convenient, yes. And then again, if once you found an error, you can just fix it and then rerun the tests. And all the tests have passed. Beautiful, 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 beautiful. So convenient. All right, so compile time express. I'm gonna add that. We don't need this thing in here. And yeah. 178. Introduce binary operations to X for AST. Best ASM compiler so far. Yeah, so I really want to make it like really powerful at compile time. So it's going to even have like a type system at compile time. Holy shit, it's gonna be so awesome. I have so many ideas for this thing. Yeah. Compile time, there we go. So that's so cool. All right, let's create the pull request. Introduce binary operations to expression AST. So later it will be possible to add more of these things. Already bloated. It's only like 3,000 lines of code. Not that much. Look at that! Microsoft Visual Studio has failed. Yes, of course. Of course. Let's see why. Unary minus operator applied to unsigned type and god fucking damn it. Okay. Well, that makes sense actually. That actually makes sense, I think. 2286. Okay, so it is actually that, but it depends on how you treat it, I suppose. Is that how we do that, by the way? I mean, it's two's complement. What do you want from me? I don't want to deal with that right now. Okay. So in case of this, it's a negation. C tilde. It's a, yeah. Basically, it negates all of the bits of the number, bitwise negation. And +1 is negation in two's complement. Two's complement. Yeah, two's complement, negation. So yeah, essentially, invert all bits and add 1 to the result. So essentially we use unsigned 64-bit integer as a container for both signed and unsigned, right? For both signed and unsigned. And when I do negation, right, so I guess it's a reasonable solution. So okay, so maybe I wanna do something like that. More cross-platform way to negate integer literals. Go to the white page. It was God damn it. Are you reading a book or something? Can I go back, please? All right, I have an idea, by the way. Disable theme. Is that bad? Okay. More cross-platform way to negate integer literals. What if somewhere the numbers are not twos? Complement. It's a default Emacs theme. Okay, enable theme grouper. Okay. Sorry, nothing personal, man. People are unsubbing. I cannot continue using it. This is what it is. No, nothing personal, just business. Alright, everything seems to be working. And to be fair, for my eyes, bright theme is not really that great. So, yeah. Okay, everything seems to be so compile. Yeah, compile time expert. And so then try to fix MSVC build again. And let's push that. I mean, to be fair, quite often MSVC, when it fails with these warnings, it kind of makes sense. So, again, yeah. It's so cruel. I didn't believe that I will be able to pull that off, but I managed to pull that off. Compile time evaluation. So we have a base for the expressions and stuff like that. Holy shit. Oh. And for example, now, if you have a string, like not right now, right, but later, you have hello, right? And maybe to quickly push an address after the string, you don't have to do shit like push hello, then push len hello, then do plusf and stuff like that. To push an address after the string, you would be able to do something like this. And that will be computed at compile time, because the address of hello is known at compile time, the length of hello is known at compile time. We can just sum them up. So you don't have to do that at runtime, we can just do that at compile time. And that will basically result in a single value being pushed into the into the stack. So that's gonna be pretty cool. That's what I want to achieve here, essentially. Jit when? We'll see. We'll see. Yeah. And once you have this like mathematical operations, you can have like layouts of the memory and stuff like that. Oh shit! I was also thinking about like a macro system that will let you define, like take a piece of code or in Bosom and turn it into a macro that will be pasted when you call this macro. And maybe using that macro language, we'll be able to develop some sort of like structures, right? So you'll be able to define a structure in the memory, and it automatically recalculates offsets depending on the sizes of the fields of the structure and whatnot. That would be actually pretty cool. That would be actually pretty cool. Okay, so the MSVC has been fixed. So let's actually report all of the errors, all of the to-dos that we introduced. Report prepend body introduced in, and I wonder how many of them did I make. Okay, there's no way to get the length of the stream again. It's not stream, string. Alright, so one more time. I removed it. Oops. Alright, so but that's true. Yeah, compile time. Some can only work with integers. That's true. More cost to negate integer literals. That's true. Better error reporting on token kind plus in. What's up with the token with this thing? So. I see. Okay. I can probably do something about that. So essentially, yeah. Oh shit. Oh, I'm sorry. All right, sure. Works. Thank you. I need to make a donation, so donation option. Essentially, for $100, I will run a random shell command on my machine. All right. So let me think how I. Oh my god, I cannot do that. Chat. Oh my god. Come on. I also want to pee so hard. Oh my god. I sent the zip bomb to my teacher because I forgot to do my homework. Hopefully I don't get expelled. Haha. No one, both. I'm not gonna run this one. FL FMT error. Expected primary expression, but found as, and I'm not even mad. Okay, so location, and so it's gonna be token kind name, I guess. Token kind name. I messed up the command, sorry. Why are you apologizing to yourself? Well, I mean, it's not a bad idea actually. Sometimes I blame myself for my decisions. Maybe to stop blaming myself for my decisions, I should probably just apologize to myself. Maybe I will forgive myself. Who knows? I just formatted the USB drive as exFAT since he was using Vista. Oh. Sort of what? Okay, everything seems to be okie dokie karaoke, but I want to test the following thing. I'm gonna do a push plus. What's gonna happen? Expected parent expression, but found plus. Yesu, kawaii desu. Okay, looks good to me. Okay. improve error reporting and stuff. Push that right into the repo. Okay, that's cool. We'll have to wait a little bit more. Our daddy told us not to be ashamed of our waifus, especially if they're cute and all. Am I right? Okay. It's pretty cool. I like that. I'm so proud of this shit. Holy fuck. So now I can add more. By the way, Heroes of Plus, have you seen what we implemented? Have you fucking seen what we implemented? Holy shit. So this is what we implemented. Look at this shit. So you can now define bindings in terms of other bindings with arithmetical operations. You can have inline arithmetical operations, and all of that shit is computed at compile fucking time. Isn't that fucking amazing? That's absolutely fucking amazing. I can't help myself, Jiang. I'm sorry. You'll have to deal with that. And furthermore, if you try to cycle them, right? So for example, this is a cyclic definition. Looks what's gonna happen. So we're gonna recompile everything. And cyclic binding definition. It detects the cycles. So it's basically it doesn't depend on the order, first of all, because it's a second pass, two-pass compiler. It doesn't depend on the order. If you try to do the cyclic thing, it detects that and reports an error. Perfect. Holy shit, I'm so proud of myself. This is so cool. Yep. So, it's interesting. Recursion has been banned. I will think about it. Like, to enable recursion for the bindings, you need somehow to have a base for the recursion. Right now, we cannot have a base for the recursion. So maybe we're gonna have some sort of like conditional translation, right? So maybe you're gonna have like something like if, right? If, and then you can define macros as a functions and whatnot. So in that case, we can try to do something. If condition, and then, yeah, it's gonna be similar to the preprocessor, but this is a BOSM directives, and BOSM directives have a full access to the translation context. It's not a separate step, and that means we'll be able to do more. We'll be able to do more things. So that's pretty pogue. Oh, another cool thing, by the way. Technically, I think, again, since okay, I'm gonna show you something cool. This is fucking amazing. To demonstrate that preprocessor directives are not preprocessor, right? They're not a separate step. I'm gonna write the following program. It's gonna be test BOSM, right? So we're gonna have an entry point, but you know what's interesting is that a label also creates a binding. And you can define bindings in terms of other bindings. So that means you should be able to define this binding. Or maybe it's something like 69 plus main, right? And then you, if you push it to the stack, right, it will work. So essentially what it will do, it will take the address of the main, use it as a number and add 69 to it, and then you will be able to actually push it here. Hopefully. We'll see how it works. Entry main, and let's try to compile this entire thing. It's gonna be bin build bin. Oh, I'm so tired. Holy fuck! I'm really sorry. Build bin BOSM test BOSM test BM. Right, so it compiled. Then we're gonna do debosm, and then we're gonna disassemble it. So what's interesting is that it pushed 69. This is because main was the address of the main is 0 because we don't have anything above. But if I add another instruction here, for example, push 0, right? So that will offset the address of the main. So let's actually try to compile that and run it, and there you go, it's actually 70. You see, you add more instructions here, and the n increases because the value of main increases, and so on and so forth. So these bindings and labels, they are interconnected, they are the same thing, right? So it's not a separate step, it's a part of the same thing, of the same system, and everything can reuse information about each other. So yeah. And soon I'm going to introduce type system. And according to the type system, if you define a label, the type of the label is going to be instruction address, right? Instruction address. Then you will be able to define types of memory addresses. And for example, the runtime, not the runtime, but the compilation will check if the type's compatible or not. Push 0 is never executed. Why is it in the final binary? Where is optimization? We have an issue for optimization. And we'll work on that at some point. Do you need .len then? .len then. Not sure what is .len. Oh, by the way, I removed .len because it's yeah, it created additional problems here. But I created an issue to re-implement it. Yeah. Oh, and by the way, so I want to implement .len as len hello, right? So essentially I want to have the following thing: hello world, right? And then I want to be able to do the following thing: push hello plus lang hello, and that will push an address after the string. And I think it's possible to implement that. We'll only need to introduce the AST node for function calls, like function calls, and then have a built-in function len, right? And then we'll be able to do this kind of stuff. Just remove everything before main easy optimization. I think we can do better than that. I think we can try to emulate execution starting from main and see what parts of code are 100% never going to be reached, and just illuminate these parts of code. This is some of the things we can do. So it's sort of like a meta evaluation, right? That doesn't really perform evaluation, it just checks whether we touch these parts of code ever at all. So we can try to do something like that in the future. Anyways, so all of this is cool and all, but I'm already streaming for more than 4 hours, chat, right? I'm already streaming for more than 4 hours, and that means it is time for me to go. I'm really, really tired. Thanks everyone who's watching right now. I really appreciate it. Have a good one. And I see you, guess when? I'm gonna see you all tomorrow. Tomorrow, according to the schedule, we're gonna be doing a random one-off stream. That is right. So we're gonna pick a random topic and we're gonna stream it for the whole Friday. Isn't that amazing? Isn't that amazing? So yeah, check out our schedule for more information on different projects we're working on. Check out our bots channel for offline binge watching of the Tsoding streams, and also check out our Discord server for offline discussion with the community. And that is it, boys and girls. That is it. Thanks everyone. Love you. Mwah.